Testing 1, 2. Uh-oh. Hang on. Okay, it should be live now. You should be able to hear me. Okay, good. All right. So let me back up here. I was telling my story. So anyways, this is, I'm going to be calling it PlyQ. It is going to be a brand new programming language from scratch. I'm building the whole thing. And it's going to be a low-level programming language, kind of like Rust. And, or even like C++ in a way, or Java. You know how Java has their own virtual environment that they run in, their own little environment, and they run it on any type of hardware, any computer? That's exactly what I'm going to be doing here, but my virtual environment is going to be a quantum computer. That's why I call it the LLQVM, which the LL stands for low level quantum virtual environment, for virtual machine. Even Rust, they have their own low level virtual machine that they run on. So I'm going to be taking that and going to be building upon that itself. And then later, like right now, I'm going to be writing it in Rust, but later I'm actually going to redevelop it in its own language. What's up, Vivek? How you doing? So just to give you an idea where we're at here. So this is the architecture for the low-level QVM. This is the virtual environment part of it. And inside of here is, this is the part that's going to be running on any hardware. You can run it in a CPU or GPU. And the core programming language is going to be on top of that. And it's going to be running technically inside of this. So I have to build this part first before I build the rest of it. But I do have the architecture for the main language, which is the PlyQ here. And the way I want to build this, it's not going to be object-oriented. It's going to be more like how Rust does theirs, module-based. And plus you'll be able to, when quantum computers start to come out, I'm going to have a quantum computer type language in here that you can run. Like if you have real tough algorithms, it'll do algorithms super fast because it's a quantum computer. And I'm hoping to be able to get this at a point where it can run much faster than, like I've already tested the virtual environment for the quantum computer, and I'm already faster than what my CPU or GPU runs inside the environment. And I've ran it on some intensive algorithms just to test the speeds and the difference. And I am like 1,000 times faster already running any type of algorithm inside of it. So that's what gave me the idea to go ahead and create a language that you can program in that runs that as the environment. Hey, Keeps. In general programming, I've been programming for all my life, but I'm not a software engineer. I'm going to be learning as I'm doing this, and I'm hoping you guys can learn with me. So this is my first language I've ever written. I've never written one before. So I have this idea. I've done some prototyping and testing it, and so far it's working great. So I'm going to be using my tool here. It's a Plyrium Forge. I'm going to orchestrate this. All right, so what's the first steps we're going to do based on what we already built? So we want to make sure that the LLQVM is up and running and it's functional, because we're going to go ahead and build on top of that. We're going to build the actual programming language for PlyQ. And again, this is not going to be object oriented. It's going to be more like Rust and a module based. Again, read all the documentation if you need to know where we're going with this. What's up, Fearless? Hey, I'm actually going to be building my own programming language here. I'm calling it PlyQ, and the Q stands for quantum. And it's going to be a quantum computer in a VM that's going to run on any computer, any hardware. Yeah, that's fine. And when we get the LLQVM up and running, I want to test the speed of it to make sure it runs faster as a quantum computer or quantum virtual environment than what a native machine can do in both CPU and GPU. That's going to be the core function of the LLQVM. You're hoping the Q would stand for quad? That would be awesome, wouldn't it? No, it stands for quantum. So I built an actual quantum, a virtual environment quantum computer. And for my computer, I ran it both in the CPU and the GPU. And I did some deep algorithms. In fact, it's way up here. And I was doing some speed tests. And I'm able to get it running faster and produce faster algorithms than what your native computer can, like 1,000 times faster. Hang on, let me find it here. This was me sketching out my idea. So right now, so these are my tests right here using different types of compiled oracles for the quantum computer. And this is how much faster it is than the native, like 2.08 times faster than native GPU. And then we're doing different versions of it, like the X8 and the X8R64 here using the end-to-end. So we got a 1.49% and 1.27%. But I was actually getting even faster speeds than that. Like right here, it speed up 4.75%. So the VM compiler online. So this is native GPU doing brute force on algorithms. And this is how long it took them to complete the algorithm versus how long mine took to complete the algorithm inside my virtual environment. And I'm going to build upon that and make it even faster. And this is just using Python. I'm going to build this with Rust. And then on top of that, when I'm done with that, I'm going to rebuild it with my brand new language that we're going to build. So that's what I'm excited for. So we're going to have some super fast programming language here, I'm hoping. Hey, thanks, Fearless. I hope it's a cool idea. We'll find out. Benchmark, each benchmark should report. Yeah, go ahead and let's go ahead and get that done and get your team on it. And we need to get some testing done. Before I do that, hang on here. I want to change. They're fine, but my coders, how do I change the efficiency here? Skills, hooks, hang on here. How do I, in the CLI for codecs here, you're set to GPT-5.5 medium. How do I change you to high? I forgot how to do that. I'm crazy. Hey, I'm all for it, man. Whether this is either going to work or it's not. This is going to be an awesome experiment or a failed experiment. Either way, we're going to learn from it. That's what I'm hoping for. And a brand new programming, we haven't had a brand new program language in a while. And this is something, of course, this could be open source. And if it gains enough traction and people start developing on it and stuff, oh, that'll be freaking amazing. And we could start developing, I mean, that's how Java started. That's how Python started and all these other programming languages out there started. Yeah, but how do I change it inside the CLI? It's like / something. What is it? Is it effort? No, it's not effort. I don't remember what it is, guys. What's up, Nico? Glad you came over. By the way, I have something to show you guys. I told Nico I would show off his website when I stream next, so I want to do that. It's Affiliato, right? Is that what it is? Affiliato? Oh gosh. What was the website? Nico, spell it out for me in chat there, and I'll pull it up. Oh, that's awesome. You're welcome. I think the badge idea is a good idea here. So okay, so if I go model, and then 5.5, yeah, that's current. Oh, that's okay. So that's where you do it at. I want to keep him at medium. However, I want my coders to be high. There we go. And then high. U2. And then these two I'll keep, I'll keep those medium, those high. So that should be good. All right. Okay, I got what I wanted. So go ahead and let's implement the plan to get the benchmark going. Affiliato, that's it. That's the term. Okay. So I'm assuming this is it here, affiliato.com. And so what Nico has built here was, this is an application that you can create affiliates for your websites, for your applications, or whatever you have out there. And this is like a one-stop place that you can see all your traffic coming in that's being redirected to your website. And you can create an affiliate program for, let's just say, some people out there that has their own YouTube channel or their own TikToks, and they can actually generate their own link and share that on their platform or their social media. And when people click on there to come in here to or go to their website to purchase whatever product or service they're selling, they'll get paid whatever percentage that company sets for. Affiliato, how this works, it manages that for those companies. So whether you have a Shopify or a basic website or an extreme, like a high-end SaaS website, so Affiliato will do all of that for you. I don't have an account, so I can't show you the inside. Yeah, it looks like you have to sign in to get an account here. Does it have big holes in it? Hey, by the way, Nico, if you want to know if your website's secured or not, Smart Edit here, he'll let you know. And I highly recommend listening to any advice he has. So if there's any leaks or holes or security issues with your website, you need to get with him. This dude is very smart. So just to set you guys up. But anyways, that's what he's building here. It's I can't show the inside. I don't have access to it, but it's a very cool website. I do, and also Nico, he has his own channel and he live streams. I recommend you guys checking out his live stream. He actually shows the whole inside. He can go through and he can answer any questions you guys have. So, but anyways, that's a cool site there. All right, so let me come back to here. So the programming language, I have, I'm going to create some samples and stuff here. So here's like some examples here, and it's going to be like every programming language has their dot whatever. Mine's going to be .plyq. before it's compiled. That'll be the actual programming language. The extension. And then here's some examples. You could also set how many qubits you want for your virtual environment. That is done in the right here, which is the LLQVM. Thought I had a sample here. But this is, you can actually set how many qubits you want to run, how expansive that is. Oh no, you could do it right here through the apply language. So like here, this is running 12 qubits, and this will run for, here's the target and how many rounds, and this is how fast it'll shoot in and how many qubits you actually have. So of course, the more qubits you have, the more space it's going to take to run the virtual environment. And I'll explain all that later when we get to that point. But this is the system architecture here, the full stack. So we got the bytecode and the runtime, and that's the back end. Then we're going to have CPU reference simulator, sparse simulator, GPU CUDA backend, WebAssembly, embedded no runtime backend, and future real quantum hardware adapter, which in the future, when they start selling quantum chips, because they already make them, and pretty soon they're going to exist in your computer or GPU or CPU, this programming language is going to be ahead of the game, going to be able to write in quantum code and be able to read and write those chips. So that's another reason why I want to do this, because we're getting real close to having that hardware. Yeah, so this isn't a sister language to Python at all. This is going to be its own language. It doesn't, there's no other reference out there that I could think of like it, what I'm going to be building here. Because you're actually technically running a program that's going to be running inside of a quantum computer on your computer. It's a virtual quantum computer. And you could run full apps, desktop apps, websites, it doesn't matter. It's going to be based on this quantum VM, virtual machine. Why are you doing code? Why is it validating? You're the director. Why are you looking into code and validating and all the other stuff? You have a team for that. I swear. Codecs can be dumb sometimes. No, Fearless, it's not going to be similar to Python at all. In fact, so here's my goals. This is what I wanted. I wanted a readable language, but it's got to be a low-level language. That's where the LL comes from. It's a low-level language like C++ or Java or C#. And it's not going to be object-oriented, but you can do object-oriented if you want, but that's not going to be the main focus. So if you want classes, if that's the style you program, you can do that. But it's going to be modular-based, more like how Rust does it. What's up, Con? Yeah, so if you need any validation done or anything like that, you have auditors, you have researchers. And also, so here's the other thing. We are going to do unit testing. Everything we do, we're going to have unit tests for. We want to make sure every function, every method is going to work as intended. And by the way, when you guys vibe code and you say, hey, and make sure it's secure, you say something like that, it's not going to make sure it's secure. You have to go in there and make sure it's secure. You have to identify where those gaps are. And this is something I'm learning as I'm developing, as I'm going and vibe coding. You can't just tell it, hey, make a pretty website and make it secure. That would be nice, but it will not make it secure. It doesn't even think about security. If you don't understand security, I'm actually building a tool for that too, and it's looking really good so far, but I'm not done with it. It's a little ways off, and I'm going to make that open source too. But anyways, for security wise, you want to, anything you do, whether it's a desktop application, web application, especially web application, or anything that has any API communication, any type of callbacks or registering subscriptions or anything like that, AI does not secure that. There's so many holes, there's so many leaks. So that is so important. Oh, that's awesome, Fearless. All right, and then also when you do the unit testing, I need a full code review, and I need the auditors to go through and audit the entire code base for any gaps that are missing, and we have to document everything we're doing. So this is going to be, I can't just vibe code. There's another term that's out there called agentic engineering. That's a little bit different than vibe coding. Agentic engineering is you can still have your AI do the coding, but you have to have your hands on and review the code. You have to understand exactly what each part of your code's doing. Vibe coding doesn't do that. You just trust the AI to do it for you. So, and I vibe code a lot. But in this case, I actually want to incorporate agentic engineering into this, especially since I'm building my own language. I want to make sure I understand every part of what's going on. And so it's not really going to be vibe coding. It's more of agentic engineering on that part of it. So anything that's happening here, like here's some examples here. This is my costly search. Let's open that with Visual Code. Hey, it didn't open. Why didn't it open? Can I do that? There we go. All right. So I'm going to create a plugin for Visual Code, so you can have the color syntax and all the other stuff. But again, this is how you set up your VM or your virtual VM. And I'm going to have predefined settings in it. So most people won't even be touching it. But this, like I said, this is for low level development if you want to get that low. And you can do high level as well. So this is the main part. All the Python stuff. So we're not writing this in Python. And I actually did some prototyping in Python. And we need to get rid of all the Python scripts and rewrite everything in Rust for now, until we can start writing things in our own programming language. No, you don't have to read a whole 1,000 lines of code or anything, but getting an understanding of what your program's doing now is very important, I think. Yeah, this is when I was testing it earlier today. But the first part I'm creating is the LLQVM, and that's going to be the core of it. And then everything's going to be inside of that. And that's what we're building now. And then when I actually get the actual programming language working, I'm going to rebuild the LLQVM, not in Rust, but in my own programming language. That's what I'm hoping to be able to do. Oh, that shouldn't have copied over. Let's delete that. That's not needed. Yeah, all these tests need to go. I think that's it, just a test. And this QSLVM here, which this is what I was I created earlier to run my speed comparison to see if I can get my virtual quantum computer run faster than my native CPU or GPU, running the same algorithms. And they're complex algorithms on top of that. So, and I was able to beat it like super fast. And that's what gave me the idea, you know what, I could take this further. Most of this is going to be boring. We're validating code. We're going to make sure everything's good. I mean, you're not going to see any visuals. This is all going to be back-end programming. Might be worse than feature stealing. I'm not familiar with any of those. The Open QASM, I'm not familiar with that. Quill, I'm not familiar with. Rigetti's QVM, I'm not familiar with those. So those are probably quantum VMs also, but are they actual programming languages though? Are they actually developing an entire programming language on top of that, like JavaScript or Rust? Because that's where I'm going to set. This is exactly what I'm going to be doing. But if you're saying Open QASM is an actual programming language or Quill, then they're already ahead of me then. I didn't even know those existed. So let's see what we have here. So the folder, the QSLVM was prototyping that I did earlier, and under test was also prototyping. We don't need to worry about those. We could actually, you could archive those. So create an archive, put them in the archive, and do a git ignore. We also need to set up git on here. Oh yeah, you already did. So do a git ignore on those because those aren't going to be needed at all for the project. Also, make sure the docs are up to date. And the first thing we're going to test is the LLQVM to make sure that it's going to run, and we had to do some benchmarks against it, against the native GPU and CPU. Yeah, so that is going to be where mine's going to be different at. I'm going to make it where anybody can pick it up and write programming languages, or write programs with it. If you want to make a game engine and run it on Windows machine, I'm hoping to be able to make a language that can do that. I want it to be able to run as light and as good as Rust, but faster. So it's a microarchitecture. Okay. So technically they are ahead of me because I just started today. I was experimenting with different ideas for my quantum virtual machine. And I am taking that, making a low-level quantum virtual machine. And then I'm going to be building, it's not going to be an assembly language at all, but it is going to be a full, it's not, I will include object-oriented language, but it's not going to be the core of it. It's going to be more like how Rust is designed with their modules. Okay, and you also got the team to set up some unit tests to get ready as well, right? Yeah, I'm going to have to check those out there. Here, hang on. Let's look those up. Let's see if we can steal some ideas. I'm just kidding. I don't like stealing from anybody. Now, taking what someone's done and improving upon it, I don't mind doing. So let's go. I'm going to look all these up, actually. Design goal, scope, contributor, version. So let's do this. I hate reading, ever since I own a language models here. Let's do this. So the other ones, so you got Regret. What was the other one? So I got that one. Quill. Quill's another one. Okay, let's look these up. Okay. So I'm live streaming right now. Some of my users are pointing out that there's already some virtual quantum VMs out there with their own assembly language, stuff like that. Do a full research on these and also more. And I want to see if anybody's doing what I'm going to be building here and how far along they are. Let's find out. I'm curious. I call it gleaning ideas. Yeah. When you're not borrowing them, you're just looking at their idea and be like, that's neat, but mine's better now, thanks to you. So PyQuill. So you got Quill, PyQuill, KVM, QIR, Q pound or sharp, Q sharp. I've never heard of Q sharp. CUDA Q, Quiz. So he's already this. If it's already in its training data because it didn't even do the research yet. So some of these people have been around for a couple of years now. Oh, definitely. Yeah, exactly. Hey, I'm all for that. I would love to see. So what I'll do is find out what they're doing right and what they're doing wrong. That way I don't make the same mistakes, but I want to take what they're doing right and incorporate that in mine. And because I don't need to reinvent the wheel, and then I can improve upon that. So, that's what I want to do. Good there. I want to get to the point where I can actually start writing the code. I think that's going to be so much fun. Programming in a language that you've written. How cool would that be? Yeah, I already got all the docs. But I wanted more. And that's the other thing. I have to document this thing for every step I do, for anything that's involved in it. The documentation is going to be so important. Okay, so he's archiving it. There's the README. Pi project. Perfect. Okay. And where are we at with this? So they've been focused on the test here. Good. See what we came up. Okay, here we go. Here's a breakdown. Oh man, there's a lot of research. Oh geez. Oh my gosh. Oh crap. Absolutely. Here's the research picture. Short answer, yes. There are already serious quantum VMs already, assembly language simulators, IRs, and cloud runtimes. The biggest ones are Open, QASM, Rigetti, Quill, QVM, Microsoft QIR, QuizKit AER, CUDA-Q. Oh wow, NVIDIA is doing their own. Quark, QSMIM, Amazon Bracket, and Q Sharp. Okay, so what I want to do is take the best parts of these, what's working for them, and what's not working. And I want to make sure that I'm not reinventing the wheel. But at the same time, I don't want to make the same mistakes they made. I don't want you to do any coding or anything. I just need a good summary of what we need to look for. And also, the type of language I'm going to be building here is going to be more like how Rust is built and kind of like Java in a way. So are any of these going to be, are any of these programming languages like this, and would they be able to build their own game engines on a native computer, like what we're going to be able to do. Or a desktop app, or a web app, or anything like that. Or even build a whole operating system on it. See, that's where I want to get with mine. Should have an arena for you viewers. I wouldn't even know how to do that, I'll be honest. I'll have to look in to see if I can get you guys interacting with each other, if that's what you're meaning by that. Yeah, make sure everything's getting documented. That's going to be very important for this. Anything and everything's got to be documented. We have the docs folder, let's use it. Because what we're going to do, we're going to take that, and when we build our website and our Git repository in GitHub, I want to make sure people understand every part of the language and how to use it. SteamYard. See, now you got me looking up something else here. Is it Stream? Or, yeah, StreamYard, okay. Easiest way to live stream and record. You know, that's what someone should do, is build a better streaming app. But of course, there's so many out there, though. Yeah, it looks like it's their own recording streaming software. Kind of like OBS, I guess. And that's what I use. I use OBS. Okay, here we go. This is what I was waiting for. Yes, this is right framing. Borrow their proven quantum stack ideas, but do not copy their scope. Yeah, no kidding. Most existing quantum languages are not trying to become Rust, Java class, general purpose language. The short truth, none of the major quantum language stacks I checked are really doing what you want PlyQ to become. Good. That's the answer I was looking for right there. They mostly fit here. Quantum assembly spec language, quantum instruction language, LLVM-based quantum intermediate representation, C++ hybrid, okay, high-level quantum programming language, relevant for readability type ideas. So, okay, here we go. So this is asking, can they build an operating system, game engine, desktop, web apps? So no, not as its own general language. Okay, but that's the closest, I guess. Sweet, all right. What we should avoid, do not make PlyQ only a Python SDK wrapper. Yeah, no kidding. And it's not going to be, it's going to be in Rust anyway. So let me take that and then add it here. And there we go. Yeah, now we got some real progress going. Okay, that's all gone. That's all gone. So we can just move these folders in. We don't even need these. Just put them in there. Target is good. Examples is good. Documents is good. Creates temp. And then this is for Plyrium Forge. Okay. For the memory and stuff. Perfect. All right. And let's take a look, see what we have here. I don't see archive in here. So I'm going to have to add that. Hang on here. So what we'll do, oh, no, it's in here, archive. But I want archive in general to be in there. Just archive. I don't even want that in there. So just ignore all of it. Save. There we go. All right, where are we at with this? And also to be clear, it's okay. We're going to have object-oriented, in it, but it's not going to be the focus. It's going to be more, built more like how Rust handles their language. And everything I'm telling you here, you document. I need all this documented. That way you don't forget. I wish sometimes, because I get mad at my agents sometimes. I could almost raise my voice sometimes because I just get so angry. Sometimes they just do the dumbest things. They get in that mood and they just don't do what you ask. Not all the time, but not most time, but sometimes they do that. And I just start raising my voice and almost start screaming at them. And I really wish that my speech to text reflects my anger. And sometimes it just doesn't. Sometimes they'll pick up the tone like, oh, yeah, he's mad. Yeah, primary module like Rust is modules, resources, components, capabilities, functions. Yeah. So docs only card. The researcher is not busy. The researcher is just sitting there idle. So go ahead and assign that card to the researcher. Why do I 2, 3, 4, 5, 7, 8, 9? Oh, my director. Okay, that's fine. And then, so we're empty here. Let me bring this over here. Nope, not there. What did I do here? Let's try this again. There we go. All right, this way I can view what's going on here. So we have 2 testing right now, because I definitely want some unit testing. And I can't emphasize this enough, but I do want unit testing done. And right now we have 2 cards sitting in testing. Okay. Good. Good. Let's look at, that's the band, but I want to look at, see what the back end looks like here. Um, so these are all functions here. See, I don't like Rust because how hard it is to read it. Um, I want, I love Rust for how powerful it is and how it programs, but I just don't like how hard it is to read it sometimes. Like, well, what is okay? Is that a return? Like, here's your function, and then you return instead of typing return, they type okay. See, I don't understand what that means. Let's look at the bytecode. So this bytecode here. This is important for quantum computers. The HXZ, the C naught, phase flip basis, diffuse, and the argmax. 16U8. What's up, AAD? Or Adhill? Adhill? I'll call you Adhill. Hey, Adhill. So I am actually building my own programming language from scratch. Just started today. And I'm using my own agentic development tool here at my ADE to develop my new programming language. And the programming language I'm building, it's called PlyQ. It's going to be, it'll take a low-level quantum computer or qubits, quantum computer virtual machine, and it'll run the program technically inside that virtual environment. But what makes this a step further is you'll be able to run it on any hardware. You could actually build whole operating systems from it when I'm done. That's what I'm hoping for. Game engines, operating systems, desktop applications, websites with it, back end, not front end. I don't think. I don't see a use for that. But it's going to be like Java and Rust in a way. And each one of those has their own virtual machines that they run off of. Rust has a low-level VM that's built in it, and then Java, of course, has their own environment that runs the whole Java code inside their environment. So I'm technically doing that, but the environment that's going to be running in is going to be a quantum computer. Yeah, so I'm going to be building my own programming language. That's what I'm working on right now. No, I don't know compiled design at all. I'll be honest with you. That's why I'm going to lean heavily on AI to help me facilitate that and do the research on it. So right now, I am building the low-level quantum virtual environment first, and we're going to get that built. That's going to be built in Rust. We're going to get that built, and then on top of that, from there, we're going to build our own language on top of that. Our language is going to run in that LLQVM, and then when I get to the point where I can rebuild, or like a version 2, I'm going to rebuild the LLQVM using my own language. And then my own language is going to kind of like build itself, kind of like what C++ does, and that's what Rust does now too. So that's how I'm going to be building this. So, but I'm starting at the core, which is the LLQVM, and that's going to be the environment my language lives in. And right now I got the bytecode, the error, libs, runtime, inside the LLQVM. I'm going to have garbage handling. It's going to be a low level, so there's going to be memory management and things like that. Do I know compile? No, I don't. I don't know. So, but we're going to learn together. If you don't know, you already may know, but I'm definitely going to learn. And for the ones who don't know, they're going to maybe learn. Either we're going to learn to know how to do it, or we're going to learn how not to do it. Either way, we're going to learn something. All right, let's see. Okay, everybody's on idle. Are we at a stopping point right now where we can test this and make sure it runs and all the unit test passes? I mean, where are we at with this? I would love to do some testing on this. One major factor is the speed. It has to run faster than a native GPU or CPU. All of my tests I did earlier through Python was much faster. So, and I want to make sure that this this quantum virtual machine, the LLQVM, is going to run as fast, if not faster. Hey, Pratt, no, I could definitely repeat it. I am building my own programming language. It is called PlyQ. And the entire language, you're going to be able to build your own operating system with it if you want. You can build desktop applications. It can run on any hardware, like Linux, Mac, whatever. That's the goal. That's what I'm hoping to do. Kind of like how Java is, and Rust, and C#. I'm looking, this is going to be a low-level language, but it's going to be more designed like how Rust is, but a better readable language. And it's going to have its own virtual machine that it runs in, like how Java and Rust does theirs. But the virtual machine is going to be different. It's actually going to be a quantum computer, a virtual quantum computer that you can either run in your CPU or GPU or a little bit of both. It depends on how you want to run it. And so you can adjust how many qubits you want, how big or small your quantum computer is in the virtual machine. And the entire program is going to be ran inside of that in a way. And this is also going to be where eventually I'm going to make it where you can run the language without the virtual environment also. It's going to be, you can run it native as well. So I'm hoping to get to that point. But I just started today, and right now I'm working on the virtual machine, which is the LLQVM. And we're building that in Rust first. And then after that, we're going to build our own language that's going to run inside that virtual machine. And then we're going to build, we're going to create our programming language on that. And then we'll have a first version of the actual language itself. So identify the GPU and CPU issue. How can you improve it and execute? What do you mean by that, Smart Edit? Yeah, it's going to be like Java, but you could do object-oriented with this, but it's going to be more like how Rust does theirs, which is how they do modular and I forgot what it's called. Components is how I'm going to be building this. Oh, you have to tell it how to run faster. Oh, so the reason why, you're right, I do have to tell it how to run faster. I see what you mean. So I actually already did that earlier here. Let me go back up here. It's quite a ways. But, and this is actually, everything I did here is already in his memory, in his knowledge. So when I ran this and I was doing some testing with it, going back and forth, and we kept improving on it, making it faster. Because we were We're testing it with some native and brute force native. And let me find it here. But it already knows what to do to make it run faster. But I do need to test it because I tested this with Python. I have not tested it with Rust yet. So there is going to be a difference. I want to see where we're at with Rust using the same technique we did with the Python. So here's the core. So you got the QVM source language, you got the parser compiler, the quantum bytecode, the quantum VM runtime, and then the backend, which is the sparse CPU, dense storage GPU, compile Oracle, and future CUDA and real-time quantum hardware adapter in the future. But this is the core architecture, the stack of how we're going to be building this language. But that's not what I'm looking for. Here we go. Here's some times right here. So this is all done in written in Python, and it was we were compiling Oracle cache, or we were compiling in Oracle, and these are the speeds I was getting versus the native, running some hard to solve algorithms, and how long it took, like the GPU, native GPU right here versus the VM. You know, it wasn't much difference, but it was faster. But I also ran different versions of it to see what model I want to run and get, you know, test the different speeds. I even got, where was it at here? Like this is 4.7 times speed right here. This is a huge difference. This is a VM compiled here for, and I was getting 0.004 seconds versus the native GPU brute force was only getting 0.01, so almost 0.2. So huge speed boost there. And here, when I was doing sparse entanglement, this is where I was getting some incredible speeds, insane speeds. So yeah, the sparse entanglement chain and the hard mating growth, like the sparse entanglement chain was getting 35,000 or 3,500 times speed difference running this virtual quantum machine. So that may be something we want to include right away in the low-level quantum virtual machine is adaptions for the GPU, the CUDA, WGPU, and the Vulkan, and also for machines for Mac and Linux and any other type of graphic GPU out there that we would need. Hey, thanks, Prath. You have a good day. You want me to explain, like, what part do you want me to explain as a beginner? Like what, like the virtual machine I'm building? Is that the, you want me to start there? Because that's the key part of this right now. So the virtual machine, let me start with that. So Java, this is the best way I can explain it. Java has their own virtual machine, is how it runs. So Java runs on their own environment. Let me see if I can find the best way. So their programming language all their instructions runs inside of their own VM, their own virtual machine. And it's not really using your computer's native hardware. It's using Java's built-in virtual hardware. And it's imaginary hardware that's being defined. So I'm doing the same thing but instead of using like an x86 or 64-bit hardware with a CPU, GPU, and all that, I'm actually doing it inside of a virtual quantum computer. Do you know what a quantum computer is? If not, I can explain that to you. What's up, Daz? Yeah, exactly, like how React works. Rust is the same way. Rust has a low here. It's Rust low-level VM. Rust. This is for their bindings here. Their low-level VM bindings. Well, this is Reddit. Writing it. Okay, so this will actually tell you how to write it. That's pretty cool. But it's a virtual machine that manages like RAM, memory addresses. This is where like it'll manage your bits or bytes. I'm not an expert at this. I'm really not. I'm trying my best to explain it here, the best that I can explain it. Yeah, this is not going to help me explain it here. But even Rust has their own virtual machine. So it's really, it's a pretend machine that's running on your machine is what it is. And the reason why they do that is because now they can run it on multiple hardware, on different types of hardware. If I want to run it on Raspberry Pi, for instance, that's a totally separate hardware. My language or Rust or React, they don't care what the hardware is. It's because they have their own virtual hardware that they're actually running it on, if that helps. And the reason why I picked quantum computer, quantum uses qubits. Qubits, so the best way I can explain this is do you know anything about quantum physics? Where like the whole multiple dimensions out there. So every action where everything that could have been has already been or can be, and everything exists even in different dimensions. So a qubit or quantum physics, let me simplify that. So a quantum computer a regular computer has a true and a false, which is your 0 and your 1, your on and off. Those are your binaries. Quantum computers don't use binaries. They actually have a third state. And the thing is that it can be all three, or it can be both on and off at the same time. It doesn't know until that point, until it has to happen. Let's see here. Yeah, so you got the comparison with the classical 0, 1. So standard representation. So yeah, so you got three states technically. You got on, off, and yes, it's both type state. And everything's in a vector base. So, and it's designed to be able to calculate algorithms so much faster because you can have multiple answers at once. And that's why, like Google, they have a quantum computer that's pretty close to cracking the SHA-256 code encryption, which is insane. The whole world's going to have to really change if that's going to happen. And they said they're close to it, and by 2030, they're going to their quantum computer is going to have the answer on how to crack the SHA-256 bit encryption, which is insane. I think that's wild. And their quantum computer has millions of qubits. It's just insane how many qubits. So each qubit is your state. So a quantum bit, and you have a qubit. So you got your quantum bit, which is your on-off. So like 0 and 1, and it in between. That's right. Yeah, exactly. So, and that's how I'm going to be building my VM. My virtual environment is going to be a virtual quantum computer that's going to run inside of your computer. So we're all idle here, except for my auditor here. So audit scope card, okay. Okay, so let's go ahead and get that built in right now for all the hardware. into the virtual VM. This way, and I also want the unit test run on those. And this way, when we do our benchmarking for the LLQVM, we have we can test it against a different hardware. And we're going to compare that with the native machine as well, so we can measure the speed difference based on complicated algorithms. Yes, both states are valid superpositions until you observe. Correct, yes, exactly. What's up, Mr. Dark? Dark Clues? Do I have a programming background? No. I programmed several times. Mostly as a hobby. But for what I do for a living, I'm a Microsoft 365 architect. And I work for a large company, and I manage their entire Microsoft cloud infrastructure. That's what I do for a living. But I love doing this on the side. I am not an expert at programming. I know different languages. I could write in different programming languages and write my own programs, but I'm not no expert. I'm definitely not an expert on it. So MERN stack and DSA, others than that, I have no idea about other IT paths. Oh, there's so many different IT paths. It's crazy. And trying to pick the right choice for you. I always say, find out what you have a passion for and stick with that, whatever that is. And you never know. You may not have found it yet. You may not even know you have that passion yet. But when you do find it, stick with it. And I'm not going to try pronouncing your name. You've Rajpal? You Rajpal? I guess that's close enough. So the architecture that I'm going to be building here, so this is the LLQVM architecture here. And this is the operating code, the layout. And this is 32, U32. And I have, this is for the quantum qubits and how it's allocated. Do I understand any of this? Some of it. I don't understand all of it, I'll be honest with you. I'm relying heavily on this large language model, my ADE here, to do most of the understanding for me or research for me. And I have been researching. I've been doing a lot of studying on quantum computers and stuff. I actually built my first quantum VM from scratch today, and I was running some tests with that. And I tried different methods to get it faster and faster. And I was getting to the point where I was just screaming on solving algorithms faster than what my native computer can do. And I have a beefy computer. Yeah, so this is what I'm hoping for here. Quantum simulator, future real QPU, yep. I work in IT, yes, but I do this for a hobby. Will I be Dockerizing this? You mean put it in Docker? That's a good idea. I probably should. Especially if I'm going to be writing in low level, managing memory and stuff like that, it's probably a real good idea to do that. And I do have Docker installed, I believe. Yeah, I do. So I could definitely do that. That's a good idea. I like that. And I'm gonna rely heavily on the language model here to help me build this and understand it. I'm also going to rely on my viewers' knowledge, because the people that I talk to on here, my viewers are some of the smartest people I've ran across, and you guys are geniuses. Do I play Minecraft? My kids do. Okay, so when Minecraft was created and in beta testing, even in alpha, before you guys even knew what Minecraft was, I beta tested it. I bought it. It was like I bought it exactly from the original Minecraft website, and I think I paid like $3 for it, $2.99. I forgot exactly what it was, just to beta test it. And all you could do is run up, punch trees, and collect wood. There was some crafting in it. It was so raw, and plus you had the zombies and a creeper. Or I don't even know if creepers was in it at the time. I think it was just like zombies. And I actually watch it grow to where it is today, and it's just been an amazing adventure. But I played it back in the day, but I haven't played it in a long time. Am I renting GPU time, or I don't rent GPU time. I have a 5080 card in here from my laptop. I have a NPU, a good CPU. So you're like 7 years old at that time? That's funny. Let's see where we're at here. It looks like we have 4 cards in testing. What are we waiting for on those? Do we need to get those tested first? Yeah, it's just a laptop. In fact, that's what I'm streaming on. That's what my camera is on. That's what I see you guys with. And that's what I'm using. Yeah, it's a laptop. It's a Rogue Strix is what it is. Giving this to you, it's my laptop GPU. Go to system here, I'll show you here. This might tell you. Yeah, it's a Rogue Strix G18 is what it is. So, made by Asus. Hey, Strange, I am building my own programming language. It's called PlyQ, and it's going to be a language sort of like Rust and Java combined. It's going to have its own virtual environment like Rust and Java does. That way you can run it on multiple different hardware out there. And the virtual environment is going to be a quantum computer. That's what separates this from the other ones. And I'm building not an assembly language, but an actual programming language where you can build operating systems. It's going to be a low-level language, but you can build your own operating system. You can build desktop applications. You could build websites with it, tools. I mean, it doesn't matter. It's going to be a full programming language. If you want to make a game engine, you can. Yep. All right, go ahead and start. You have the researcher and 2 auditors that are just idle right now. You got auditor 3 and auditor 1 is just idle. Go ahead and get them working on the test cards. And if you guys are curious, so this ADE here, it's called Plyrium Forge. I built this. I vibe coded this entire agentic environment here. I'll give you guys a little tour here if you guys are curious. Which you might be, you might not be, I don't know. Let me go ahead and close that out. So I have, it's got a built-in memory. This memory grows over time as it learns your project or what you're working on. It does have an editor and a file tree in here. So like here's my editor. If I want to look at source code here, here's the source code. I come in here and I could actually make changes to it. This is my topology of my director. This is the only person I control or I talk to is the director. I can talk to each individual agent that's running, but I don't. I usually let the director handle it. And I can see who's working and who's idle, and I can see what they're working on. So this is my topology here. If there's any skills that you want to inject into the into your agents, I have, this is the agent activity, the console review. So if there's any Git repositories that are, or any Git work trees, this is where it'll list all those work trees at. I'm going to have a console set up here. I'm still working on this. This is something new that I'm building onto. It has a full browser in it. So yeah, there's some errors with that. It's not perfect. Knowledge graph is not working. That's not working. That's not working. It's got a game bridge where you can connect to Unity or Unreal Engine if you do any game development. This will actually connect to your game engine. So yeah, it does quite a bit. It's not perfect, but I'm still working on it. You can't join my Discord server here? I'll send it to you. I can send you guys a link. Hang on here. Let me find it. I got you. I got you. There you go. You should be able to go. Hey, thanks so much. Also, the other tool that I built is my my speech to text. This is Plyrium Echo. This runs locally on my computer. It doesn't connect to any server, anything like that. This is local speech to text LM. It uses Whisper, so it's multilingual. And what I love about this is if you run this and you don't have a high-end computer, you can actually choose the small CPU version, and I'll change it to that, and I'll show you. It works so good. So I'm going to go ahead and switch the model here to small. And right now, it's downloading the small model. It'll get it installed, and it'll turn it on. So wait till that's done. And it runs in the CPU, and it's just as good, and it's much faster than the GPU one. So it's loading the small right now. And now I'm using the small. So now when I talk, this is using a small model. So it takes a little bit to load in the CPU, but once it does, after I start talking now, it'll be much faster. Well, that just proved me wrong. Hello? Well, okay, so it's a little bit slower. Probably because I got other things running right now. But anyways, it's local. It's it's a private thing. So what I like about this is here's your history. So anything you say or talk, it'll save it in here. You can clear it. And if you forgot what you were saying or something, you could always go back to this and you could click on it to copy it, and then you could paste it, Control V. And so you can paste it somewhere else if you want. But if you guys are interested in any of those tools, so both the ones that I'm using, it's plyrium.com. I'm plugging in my own merch here. So anyways, there you guys go. So let's see where we're at here. So we're still not done. Bring it over there. Yeah, we're still waiting on reviews here. Okay, we still, it looks like all the auditors, the researcher, and everybody's on idle right now. So are we ready to test this, or do we still, because it looks like there's still cards in the testing. Yeah, I'm catching up here. What do you think about the founder of Zig banning AI from his foundation? I think it's a great idea. I think that companies, they should be weary and know what they're getting into if they're going to incorporate AI. It has to be done right without destroying the workforce. And for him banning AI in his company and his foundation, I'm all for it. So good for him. He's setting a precedent, which is good. I don't see nothing wrong with that. Nice setup. I'm doing some quantum work as well. I have 2 laptops connected, running around 50 gigabytes RAM. I built a fully working hybrid photonic quantum sensing rig using tab lab rubies. Is that lab? Yeah. And green 532 nm lasers. Oh, that's freaking cool. Oh man, you got pictures of that? I would love to see that. How do you have this much knowledge? Self-taught. Everything I'm doing, I'm self-taught. I really am. Just doing a lot of reading, studying, and experimenting. I throw stuff at the wall, see if it sticks. Oh, that fell off, so let's not do that. I fail a lot, but it's okay to fail. It's okay to experiment because you learn from your failures. So, and I have failed a lot, and I've learned from my failures. And so this is how I got to where I'm at today. Do you prefer Windows 10 or 11? I prefer Windows XP, if we could get back to that. And honestly, 10 over 11 any day. 11 sucks. Hey man, what's the reason to creating language? What gap does it fill? It doesn't fill any gap. It's, to me, again, throwing something at the wall to see if it sticks. I'm having fun with it. I'm learning. I've never done it. I've never created my own language before, and I wanted to see what it was like from scratch, building it. And we'll see what it becomes. And I'm doing, the only difference is the virtual environment's gonna be a quantum computer virtual VM inside, and the language, the main binaries is gonna run on top of that. Kind of like how Java has their own VM and Rust has their own VM and React. But theirs is just like a regular native computer and hardware. Mine's gonna be a quantum computer that you can run on any hardware. So. I'm sorry, was on the phone. Is this a copycat bridge space? Is what a copycat of bridge space? My tool here? I mean, sure. Yes, it's exact copy of bridge space. And you want to know what bridge space copied theirs from? Go look up paperclip. And then you'll see a copy of bridge space. Who was first? I don't know. But, everyone has copies of something, right? My tool is nothing like his, and his tool is nothing like mine. So for you to even say something like that is kind of weird. What's my name? My name's Josh. He has a live version of GPT 6.0. Oh, yeah. Cost of running multi-agents. So my tool, what it does token efficiency. So right now I'm saving about 45% tokens right now. So my cost, I have only the Pro $100 subscription on Codex. And I have 66% left, and it resets June 10th. But I've been running a lot on here and running all my agents here. So I never run out by the end of the week. I'll put it that way. I always have enough. Same good old days. What quantum sensing what does it say? Modality are you using? NV centers, informatory, squeeze light, atomic effects, or something else? For my VM, I'm using qubits. It's a virtual quantum simulating qubits. So for that, here, I'll show you the quantum computer here. This is the architecture here. So this is going to be the core of the qubits and how it's ran. So I'm using RMAX, diffuser, phase flip basis, and then I got my my registry, my HXZ, and my CNOTs. The codex limits are weird. Mine just reset like 3 days before it was supposed to. Oh, that's interesting. Yeah, it's weird. I never run out. It's, yeah. So how are learning at open sourcely? Where do you find the resources like AI or something else? Well, I'm not understanding what you mean by, like, my knowledge. Like, what do I use AI for research and stuff, and I also do my own research. I mean, when I go outside or go somewhere, I have my phone and I'm researching on there, or even talking to people like you. I'm learning from. I'm getting my research from you guys right now. One very beginning question, like, what are the prerequisites to an individual need to know to start doing something as this, like writing a new program language? So I didn't know that answer today. I did not even know where to begin. I asked AI. I started the question with it was just a question. Like, my first idea, what I want to do was, I'm like, I wonder, so let me back up. I was watching YouTube, and I was watching what Google has been doing with their quantum computer. I'm like, it's amazing what they've been doing with it. And I've been researching quantum computers. I'm like, my question was, can I actually build a virtual quantum computer, like a virtual machine, but like a virtual quantum computer? And so I went ahead and did that. And I started running some tests on that. And it wasn't very fast at all. It was actually real crappy, my first version. So I'm like, well, okay, I need to get this to where it runs faster, and I could run my algorithms faster inside my virtual machine, my virtual quantum computer, versus my native computer. And I got a beefy computer. And I'm like, I needed to be able to extremely be faster. So I was doing some different testing with it and different renditions. And I was finally able to get to the point where I was screaming faster running algorithms than I can on my native machine, just inside my virtual machine. So I was like, Java has a virtual machine, Rust has a virtual machine that they run their entire programming language in. Why don't I build a programming language based on a quantum virtual machine? That's how I came up with my idea. And I'm like, this is what I want to do. And I started researching that a little bit, and here we are. So this is my first day, and this is as far as I've gotten so far. A question that started an entire new project? Yeah, that's how I start anything, just a question. I question things, and I'm like, I wonder, and I want to prototype it, and I'm like, okay, this is cool. It's becoming something. What I actually would love to do is be able to build an LLM, a large language model, because I'm real into language models, by the way. So you can ask me anything about language models. I can tell you the inside outs of a transformer and how it works, a CNN, SNN. But anyways, I'm like, what if I built my own language model inside my own programming language that runs inside of a virtual quantum computer, and make it local where people can run it on their own machines? That would be pretty cool. I would love to see that. Multimodal, I'm running NV centuries and superconducting transforms across substrates. Okay. Tabuli, I'll be honest with you, you're saying things that I'm not familiar with. I know what a superconducting is. Transmons, I'm not sure what that is. And cross substrates, I would have to get more context on that. Yeah, I feel you on that. I was doing one project, then I had a question, and now I'm working on a different project that is better. Yeah, and that's what happens. It all starts with a question, and it evolves. It really does. Like, my first thing was watching a YouTube video of quantum computers, and then wondering if I can do something like that. I didn't even realize there was other ones out there until after I started building my own, that there's other actual quantum virtual machines out there. And now look where we're at. It just kept evolving. And you know what? It may be something completely different tomorrow. I don't know. Because I'm new to this, what is the pros of creating your own language? Learning. That's the pros. I might be building something that's unique, never been done before. I know there's other. So here, I did the research already. Here's the top ones out there right now. You got OpenQASM. They actually have their own byte language. You got Quill, which is a instruction language. Microsoft QIR, which is a low-level virtual machine. And I'm building exactly what these guys already built, but I am going to be building something on top of that. Even right here, none of the major quantum language stacks I checked are really doing what you want PlyQ to become. And what I want it to become is a full programming language, like Java or Rust or C#. That's what I'm going to be doing different than the rest of those guys. And you'll be able to run your own quantum level programming code or algorithms inside of your own applications, which is, I think that's going to be pretty cool. It's just going to speed things up so fast. Okay, we're just sitting here right now. Have we done any testing yet? Any benchmarks? Man, I must be using up a lot of my CPU because it's running, my VM is running slow. That's fine. Yeah, that's so low. I don't understand. Whatever. Any last millisecond, speed up versus native. So on that tiny smoke test, LLQVM is slower. Okay, when we were testing with the Python, we were able to get it up to almost 2 times the speed, 2.75, I think, the speed of the native computer. And we have all those tests, and it's now in the archive. But look at the Python code in there and see why those were faster than the native CPU, and see if we can incorporate that into our Rust version. Man, that took forever. I gotta switch it back. Hang on here. Changing my model back. All right. It's kind of crazy how delusional vibe coders are. You know, you're right. I had a delusion of creating my whole ADE here, which I have. I had a full delusion of creating my voice to speech. I actually created one, a very cool delusion. I have a delusion here on creating my own SaaS that really works really well. I mean, my delusions are freaking awesome. I wish more people had delusions like I did. Let's see here. Ken's on an interview with the creator of Zig. He explains how his frustrations with the other language made him create one. Oh, okay. I'm just a construction worker with no education other than full stack web development. It's just hey, that's how you get started. And honestly, you know, whether you do your own programming or vibe code, or the new term is agentic engineering, where you use an agent to engineer your code for you. But either one of those, you could go beyond what you're doing now. We should recommend there are architecture issues with Rust-like languages targeting KVM, since it runs into some fundamental issues that don't exist in classical VMs. Maybe, and I may run into those limitations. I don't know yet. We're going to find out though. Complete PL, wow. That probably the issue why there's so much of them or any. I don't know. Do I plan on doing the language for real work? If this functions and works, yeah, heck yeah, I think that'd be cool. Be able to create my own tools and stuff using my own language. I would love to do that. It'd be really hard to find solid training data to get LLMs better at coding in a new language like this. Oh, well, yeah, but if this becomes popular and a lot more people start using it, they'll train their LLMs on it. And plus, I'll have full documentation on this and a website, so they can always refer to that. Have you started building this language? Yeah, I'm actually building it as we speak right now. Here's the source code for the low-level quantum virtual machine. And in fact, I think I should be, so here's like the runtime, for instance. And then I have this is the library. This is the air handling. Of course, this is for, let's see, here. The bytecode. This is what how the qubit works and how the bytecode works and the instructions. So the qubit, it runs on the HXZ and the CNOTs. And this is the instruction or the instructions for how each operator works inside the language. And this is the backend here. So, yeah, we started. Can you please explain how it works, like a working flow? Yes, I could do that. So the best way to explain that is, let me find it here. So here's the architecture. So it starts off with did I not save that? Hang on here. I know I have the, okay. So here's the architecture. So the PlyQ source language, right? You got the PlyQ typed IR, the general native IR, which is the LLM, the path to the LLM. So this is your byte level information here. This is your my low level quantum virtual environment, and this is where everything's going to be compiled into. This is the backend, and the backend is going to handle whatever hardware that's going to be connected to your machine, whether it's CPU, GPU, but it's going to be it's a quantum simulator. So I have a better explanation on that. I thought I saved that somewhere else. Let me find it here. Yeah, it's the same thing. Yeah, this is exactly what I just explained. That's not what I'm looking for, though. Can you summarize, give an explanation how the architecture works from the compiler, the byte level, all the way down to the programming language? Like the architectural flow. Well, give me an idea to building a brand new programming language? A question, an idea. I was watching a YouTube video on quantum computers, or Google's quantum computer. And then after watching that, I was like, I wanted to play with one. So I was like, I wonder if I could build a virtual quantum computer in my machine. So I did, built that using Python. And it was slow at first. I'm like, well, I wonder if I can make this faster. So we were trying different renditions on making it faster, different methods. And I was able to get it like super fast. And then after I was able to get it really fast and being able to solve some complex algorithms inside of it versus my native computer, I was like, okay, what if I built a whole programming language that uses that virtual environment, like how Java does and how Rust does, because they all run on their own virtual environments. React does too. So I was like, I wonder if I can actually build my own programming language that's based on the quantum virtual environment, because they just run regular virtual environments. I want to run a quantum virtual environments. So that's what gave me the idea to start it. And then you guys pointed out, hey, there's already some out there like that. So I did some research on it. And from what I want to do, build mine, doesn't exist yet. So there is like assembly level language. Like these are all quantum virtual computers, even Q-sharp here, high level quantum programming language. But none of them are you're able to build an operating system with, a game engine, a desktop app. You can't build those things with any of these. These are just actual, you got to have an actual either quantum computer or use assembly type language for theirs. That's all they've done. And these are the high level ones that are out there. So I'm like, I want to build something completely different. I'm actually going to build a full, it's not going to be, you can do object oriented with it, but it's going to be more like Rust on the component based and how you got your component and your, what's the other thing? Like modules and stuff. I forgot what it's called, but it's going to be a component based type language. So, but yeah, this is the architecture, how it flows. So you got the PlyQ source code, your parser, source AST, type Plyrium, the IR. This is the bytecode to the virtual environment. This is virtual environment runtime. And this is the backend adapter from the virtual environment to your main machine, your hardware, to be able to run on it. So this is the flow it's going to run. Why do I use cursor? Why don't you? Because I built my own ADE. It's much better than cursor, in my opinion. Cursor don't save my tokens. I can actually save my tokens. I have my token efficiency here. Like right now, I'm up to 46% savings on my tokens. Cursor, I can't do that with cursor unless I get some like MVP or something, or some really dumb down the skills. Set the Python speed, investigating Rust path created. Okay, go ahead and get your team working on that and see if we can get it to speed up a little bit. So you do have so you got the test there. So it's about the 2 times 2.75 times speed. And were you able to evaluate the Python code that was inside the archive so you can understand the different architecture we did on that? And is that something we can incorporate into Rust? I just learned LLM. Did you have a roadmap to make this from? No, I didn't have a roadmap. I just started building it. We're still brand new. The only thing I've built so far, and it's still being built, is the. So when I look at where'd it go? So when I look at this, what I'm building right now is this part right here. That's all I'm building right now. I still have to build, well, it's going to have the backend adapters built into it. And so technically, these 3 things is what I'm in the middle of building right now. And then once I get this built, I can build the rest of this on top of it, right? So my actual source code that you guys are going to be able to write and program in to be able to, and then you compile it, and it'll run in the local VM, the local QVM. So, but right now, this is what I'm building, and I'm currently building that right now. So this is my PlyQ here. And if I look at my crates, the only thing I have is my LLQVM. Here's the source for it right now. So, and that's what I'm working on. I literally just started this today. What are the most important skills that you think is most important and highly valuable in the future of AI and even today? Security. 100% security. Anything you do, especially when you're dealing with LLMs, is understanding how security works, because your LLM is going to fail at it. It's going to make things horrible for you if you don't understand what to look for. And even to this day, I'm still learning on what those things are, what I need to look for. So, it is not maybe, it is truth. Rust assumes determinate and executable movable memory, while quantum computation has measured collapse, entanglement, probabilistic outcomes or more. Maybe, we're gonna find out. But if you will make it work, I would be gladly proven wrong. As I said, wish you good luck. Hey, I would love to get this working. I mean, I've already built the VM, and it's already working. It's just a little bit slow right now. So sparse CPU back in first. That is the clearest and legitimate. Speed up when the state is sparse. Do not allocate touch up to 2 the power of n amplitude. Yeah. So this is what made Python not one hard-coded 2-unit test. Speedups were runtime benchmark observations, mostly from sparse representation on a sparse workload. Yeah. Well, take what you can from that and what makes it faster, because that's the only way this is going to work. The LLQVM has to run faster than a native build, and that's going to be important. Otherwise, there's really no point in having a quantum computer if the algorithms are going to be slower. For Plyrium Forge Studio, what is the preferred LLM subscription needed? Whatever LLM you have. If you want to even use a free LLM, so you come in here and go to OpenCode, you can even do that. And inside of OpenCode, you could use whatever. If you have DeepSeek, if you want to use Big Pickle, you could use any of those. So you got Kimi, Grok, and then Claude, OpenAI Codex. I'm disappointed with Claude. I've actually, I'm thinking about canceling my subscription with them for a while until they start to get their head, pull their head out of their butt. But I've been using Codex more. How is Plyrium different than BridgeMind? Just curious. It does a lot of things differently. So I have a director here. That's all I manage is just a director. I don't need to go to each individual one of these guys and tell them each what to do. My director manages and facilitates the entire workflow. And my team here listens to my director. So if my director tells coder 1 or coder 2 to do something, or how to do it, or what to do, that's my director's job. And my job is to tell my director on my vision what I want done. So if there's any research that needs to be done, that's why I got a researcher. And you can change these. Like, let's just say I have an extra coder here, but I don't want a coder. I want an architect. So I'm going to switch him to an architect. Guess what? He's now an architect. The other thing is my token efficiency built into it. This isn't just by skills. I actually have real tools in there that's pulling out certain tokens that's not needed, that they don't need to send to the cloud-based LLM. So I'm saving tokens. So I can run multiple agents at a reduced cost than you would running regular ADE that's out there. Let's see here. There's quite a bit of different things with this. So the orchestration alone is a huge difference than what these other ones are out there. And plus, you don't have to worry about running out of credits or something. I don't know how he manages his subscription, but yeah, it's just a fee, and you don't have to worry about running out of credit. I don't understand that. That's weird. Surely you get hit on cache reads. Surely you get hit on, what do you mean by that, on cache reads? Are you talking about your token cache? So I capture that. So right here is the, where am I pulling my cache at? Yeah, provider cache right here. So you do have cache, but that cache, I have access to that before it gets sent out. So behind the terminal and behind the CLI, there's an HTTP request that gets sent out to the LLM. I'm able to interject that HTTP request, which is that whole cache data that's going to be sent to them. It's just a huge, like a JSON file. And then I'm able to go in there and strip out all the stuff that's not needed before, and then recompile it and then send it to them, type thing. Yeah, the provider's KV cache. Yeah, that's on their side. Whatever they do, but I strip out that context before it gets to them. It's like $50 a month is soft credits, and you bring your API for agents. He has like $50 a month. His soft. Yeah, I don't know what any of that means. Yeah, you bring your own AI to my tool. So whatever AI you want to use. Quantum is something I really find interesting. I'm going to start researching about that. Yeah, check it out. There's actually, so the research I did today, thanks to you guys. So here's some quantum virtual machines that are already built out there. Microsoft has one, like this Q Sharp here. I didn't even know this existed, but this is a high-level quantum programming language. I don't think it's a VM, but there is some VM, like NVIDIA's CUDA. They have one here. So here's one, Rigetti. This is a LLQVM, and that's what I'm actually building an LLQVM using Rust, but mine's going to be more than that. I'm going to have a whole full programming language on top of that. And here's the structure here. So I got my LLQVM. So I got the bytecode, the runtime, and adapter. That's what I'm building right now. And then on top of that, I'm going to be able to build my source code, and then the parser, and then these other types here. So there's an order to build these. Is 1.40 the most recent update? No, it's at 1.48, I think, right now. Let me double check here. Oh, not there. Hang on here. Yeah, 1.48. That's the newest update right now. Does that say O or 8? I can't read that. Hang on. Let me zoom in. Yeah, that needs to be updated. I think it's 1.48. That's the recent update. Maybe it didn't get updated. Hang on. Let me refresh this. Oh, 1.44. That's the release that you guys will see. Mine's a little bit newer. Mine's 1.4.8. So, yeah. Exactly. You are invalidating Anthropic cache, so it needs to regurgitate so you get hit. Yes. Yeah. Yeah. I'm aware of that. So here's a little tip for you. That let me show you here. Or little not really need to know basis that I want to share with you guys. Oh, actually, it is in here. Where's it at? Where's it at? I'd hope this is in alphabetical order. Yeah, there we go. So, Claude Code, they had an issue about a month ago. They accidentally leaked their entire source code for their CLI, their CLI. Well, I happened to grab that. So here it is. So yeah, 331, so about 3 months ago. They leaked their entire CLI, their source code. I don't care about their CLI. I'm not going to build off of their CLI. This is their source code. I'm not going to steal anything from it. What I was able to do is understand it and learn from it and see exactly how their CLI is sending data and information to their LLM. So when I built my tools for my token efficiency, it's because I understand how the CLI works from the source code perspective. So it's been on all day. Maybe I got to restart the app. It's been on all day. Well, will it stay? Well, it still says it's up to date on 4.1404. That's interesting. Yeah, if you go to, oops. If you go to your settings here, what? I subscribe, refresh. What is this doing? Yeah, you better check. I probably broke something. Yeah, I'm using a different version, you guys. Screw you, buddy. I have an active subscription. Did I break it? I probably broke it. Give me a second here. Yeah, this monitor is running so slow. I don't understand why it does that. But when I run OBS, sometimes this monitor here, my main, the one that I'm streaming on, it runs so dang slow. It's like all jittery. Where is it at? You use mint-mdump to reverse proxy the Anthropic API and tamper with the outgoing request. The KB cache invalidates is real though, since the cache is amazing at cost reduction. Yeah, no, it is. It really is. And I showed you. I'm including that in the in the token savings also. But I'm using Codex, so Codex doesn't use the same type of cache savings as Anthropic does. It's completely different. But I also have Claude, but I'm prefer not to use them right now. Is this vibe coding? Yeah, technically, yeah. This is vibe coding. It's actually real boring because you're not really into code. But I've been getting in here and trying to understand exactly what's going on. I don't write in Rust. Rust is a little bit different. It's a foreign language to me, but I'm trying to learn it. Hey, is there a specific thing on your mind? On mine right now? No, nothing specific. Did you build Plyrium? Yes, I built that. I vibe coded it, actually. So let's go to here. We're going to relaunch that. Let the teams load. This takes a little bit. Yeah, it's these team just has to load them. CC is probably the worst source to learn from since it is one of the worst harnesses to run Claude API on, which is funny. Okay. What server service are you using to use for signing into your service? What server service are you running to use for signing into your service? Are you asking me for my application if there's, if they have like a cert service or like a certificate signing? Is that what you're asking? No way, really? I mean, you published it and now like earning from it? Yeah, I am. I'm earning from it. Let me show you my, here, this is my current ARR. Whoops. Oh, I hate OBS and so damn slow. Yeah, it's my current AR right now. It's going up. I'm earning from it. Bring it back over here. Let's exit that and then reload the terminals. There they go. This will take, I ought to bring it over to this other screen for now just because it's faster. Oh yeah, there we go. Oh, much faster. This screen is just stupid. And it does do it all the time. It just does it once in a while. I don't know what causes it. OBS is what's causing it. Because once I close OBS, boom, everything's working fine. Keep it up, Grandpa. You got this. Hey, I've been called Gramps, Grandpa, Old Man, some other names too. So yeah, I'm actually not a grandpa yet. I have children, but none of them has kids. I have dogs. They have dogs. Maybe I'm a grandpa to them. Hey, believe it or not, I've had gray hair since I was 25 years old. I had full gray hair since since I was 25. We use WordPress for having people sign into my app so that then they sign in and they collect their email address and stuff. Okay. Your kids interested in tech? I mean, in their own way, their games or like I have my daughter, she's in the Air Force and she's a biotech. She manages hospital equipment and she can rebuild any of the equipment. Like she could take apart an MRI machine all the way down to every single scrap and rebuild it from scratch. But that's what she does. I have another daughter who likes to play video games. Too much stress? Nah, it's not stress, man. I just wanted the George Clooney look. I just didn't get his good looks. I just got the gray hair. So where's the rest of them? So Plyrium, I had to close it out and restart it, but I'm only seeing one team member, which is Auditor 4, that's loaded. I don't see the rest of them. And looking at topology, I do see that they're loaded in there. Can you see what's going on and see why they're not loading? It was asking you, what do you use for backend sign-ins? If it's, I don't know, Firebase or your own database. Oh, I use, for my website, so I have Vercel, and I use Superbase, and I have Stripe. For my I don't host any of it. It's all hosted by Vercel, Superbase, and Stripe. If that's what you're asking. Your gray hair suits me. Thank you. Actually, I do have a full set of hair. I mostly don't show off my hair, but you know, I'm not bald or anything. I have a full set of hair. I just keep it cut short, and I like wearing a hat. So, but I have hair. Hello, old man. Can I ask you what this is? Don't swear me. Don't swear you. Don't get mad at you? Is that what you're saying? No, I love talking to you guys. You guys can ask me any questions you want. I am building my own programming language from scratch. That's what I'm working on right now. What's up?
It's saying Disney Plus needs parent approval.
What are you trying to watch?
The doctor!
You know what's stupid? It's Disney, and it needs a parent approval. How stupid is that? Hang on here. Do I have to log in?
It's the Microsoft.
Oh, the Microsoft? What?
Yeah.
I wonder if I got an email on that.
Refresh.
Allow this? Is this what's asking? How stupid is that?
It never did that. That's why I'm like,
No.
it could be. I've always been able to watch it.
That's so stupid. I'm going to have to change this where this won't happen. Kylie, Green. Where are you? Oh, you. Okay. Is that it? I mean, did I do it? You good?
Okay.
Yeah, you should be good. Okay. You're a big cool old man. You were awesome. Well, thank you. I am, how old am I? 46, 47, something like that. That's how old I am. Grandpa ore farming. That's awesome. All right, where are we here? What's going on? So, can you go ahead and close out all the ones that are showing that are in your roster, and make sure the terminals aren't running in the back end in the processes. And if they are, go ahead and close those out, because I don't want no rogue terminals running. And then we're going to relaunch this team so we can keep going. It is still doing it. Oh, that's hot.
Yeah, it has been hot. Like,
Well, you got to blow it out.
how do you do that?
It's actually not that dirty, though. Yeah, it's not dirty. Canned air. I have canned air somewhere. Oh, where's my glasses? This is old man move right here. Put on my glasses because I can't freaking see. They're all calling me old man and grandpa. Yeah, look, grandpa.
Did you tell them your age?
40. I think I'm 46 or 47.
See, this is old man. He doesn't
Yeah.
even remember his age. Stop counting.
I don't care what my age is anymore. Doesn't mean anything.
You sure?
My age? No, I don't.
Okay.
Web safety? Maybe that's where it's at. Share my activity? No, I don't care about your dang activity. Burroughs Pizza? What?
Because I looked it up.
Oh, here we go. 56 visits. Yeah, you're allowed to be on there. What is this crap?
I don't
All this because you wanted a freaking mod.
Hey, Minecraft wouldn't connect without family share.
That is so stupid.
That's what I said. I didn't need it before. No, because it's my entire computer, Dad. It's
Yep.
like, you know, remember how it had a search bar right there?
You know, you had a
It's
virus
gone.
the other day. Hang on here. Yeah.
Is that my fault?
Allows us this entire website. Yes. Yes.
That virus messed up my entire computer.
Why is it taking me here? Is it going to go? I allowed it. The good doctor.
Yay!
There you go.
Thank you. Thank
You're
you.
welcome. Wow. That was about the dumbest thing I ever seen.
You want to blow on it?
No, I told you it looks clean. You can take the can of air and do it, but it looks clean.
To the bottom?
Yeah. I don't see no dirt or dust or anything, dust buddies. It looks clean.
But why is it so hot?
Because it's an AMD. AMD's getting a little hotter than NVIDIA's or
When I
Intel.
was pressing the 4 key, it like burnt my hand.
Well, don't touch it then.
Well, I have to.
You. Okay. Sorry about that, guys. Okay. Where am I? Where was I doing? What was I doing here? Where was I doing? What am I saying? You know, that could be what the issue is. Hold on here. Oh, man. Come on. Quit doing this to me. Oh, it actually crashed on me. I need to reload the director here. What the hey, man? I'm gonna stop all, confirm, and reload the director, and then reload the team. Maybe. Oh, you know what? What an idiot. I told my director to make sure that it closed the terminals for the team that may still be there. So it did, and it closed himself. So he kind of self-deleted himself. That's so funny. That's why he stopped working. Fixing things, making stuff, and all that is just too awesome for me. Okay. Hey, Fearless, you have a good night, man. I'll see you next time I'm on. Your daughter does the exact same thing? That's awesome. I love my kids. I really do. Night, night, Grandpa, and going to sleep. I'm tired. You have a good night. I just want to test it. Come on. Well, technically, I don't have a team yet. Ooh, hang on here. We want a coder. And then we want a coder. Oh, there's my auditor. Whoa, where'd he come from? Don't you be spawning things without me knowing. Yeah, I'm creating a team right now, so you don't have to worry about spawning them in. And then let's do, I want an architect. That's going to be important. And then I definitely want a writer because we are going to be doing a lot of documentation. Quality assurance. And I think that should be good. Because I don't need a researcher. Okay, go ahead and check your roster, introduce yourself to your team, let them communicate back to you, and then you're going to have to reassign the cards. There's some in testing, and you should know what your team is capable of doing and go and get them started. You too? All right, you have a good night too, Code. And you know, I'm going to be right back. I'm going to step away for a minute. Let me get you guys some music at least, so it's not too boring. Give me 1 second here. me see how loud that is. Hang on. But right there, that shouldn't be too loud, right? But enough where you guys can hear it. There we go. Dude, the code, you can, if you want to copy me, please do. I will be happy to see someone, take what I did and improve on it. So, and you can make whatever you want, but if you want to copy me, go for it. I have no shame in that. You guys can, I want to see more of you guys do what I do. I think that'll be so awesome. I enjoy doing it. I have fun doing it. Talk to you guys later for the ones that are leaving. You'll be back tomorrow? I'm going to be streaming tomorrow also, so we're going to be good. It's going to be my weekend. Tomorrow's Friday. I don't work tomorrow, so I got Friday, Saturday, and Sunday off. So you guys have me all weekend. Like right now, I would have already been in bed because I'm an old man. But since tomorrow's my Friday, or today was my Friday, and tomorrow's an actual Friday, but today was my Friday, I'm going to be up quite a long time here. I want to get to the point where I can actually start writing programs with my own programming language. That I can't wait for that. But I'll be right back. There we go. I'm back. Did I miss anything? What's my big boy job? I'm a Microsoft 365 architect for a big company, and I manage their entire Microsoft cloud infrastructure. That's what I do for a living. That's my big boy job. This is not my big boy job. This is my hobby. You guys are starting to quiet down. Don't forget to make sure, right, I have a writer in here. Make sure that the writer's documenting everything that's going on as well. We need to document every part of this so we have a full understanding. And then we're going to do a benchmark test. So when we get to the point where we can benchmark it, we want the LLQVM to be faster than the native processors. Ah. Let's bring this over here. And we got 3 in progress and 4 in testing. We have 4 in testing right now. I know we only have 1 auditor. We also have a QA. Let's get them working. Right now they're idle. I want some unit tests done as well. Are you actually writing more? Hope you are here. Let's see here. Is it in here? Yeah, so here it is. Here's the actual application. So I built it here. Good. And so backend portability roadmap. This is what I want to see. And for you guys that are just getting on and not sure what I'm doing here, I'm building my own, not you. Where's my, oh, did it actually close down my codecs? It did. But I'm building my own programming language. And it's going to be like Rust in a way, and JavaScript and React. But instead of using a regular virtual machine like they all do, I'm going to be using a quantum virtual machine. So it's going to be using qubits. And this is the flow of the tech. Right now I'm building the LLQVM. So the bytecode, the runtime, and the adapters. And then after that, I'll be able to build the actual part the source code that you're going to be able to develop in. And then from there, we'll have the parser, which will break it down into binary, and it'll run the bytecode into the LLQVM. So The target platform is Windows, Linux, Mac OS. Yep. No GPU dependency. Nope. So CUDA, WGPU, Vulkan, feature hardware and cloud adapters, yes. Making sure it's on target here. And so right now I'm building it in Rust for the LLQVM. And then after I build my own language, I'm gonna rebuild my LLQVM on my own language, my own programming language. So it'll be 100% written in its own code. You're a bug hunter. Do you recommend using the tool in my workflow? Looks really interesting. For bug hunting, I mean, you could. So check this out. This is so slow. Not here, hang on here. I actually have another project I'm working on. Let me pull that up here. I think this is more of, I'm calling it Securium. Go ahead and launch Securium. It's right now, it's in its very early alpha stage, and I'm gonna make this open source. So what this is gonna be able to do is for you to test for any bugs and vulnerabilities in your own applications. And it's gonna be tied to databases like Metasploit, Microsoft's database for exploits and vulnerabilities, GitHub database for exploits and vulnerabilities, and there's like 5 other ones. It's going to be able to pull the latest vulnerabilities, and you'll be able to run it against your website or your application and do a full scan on it, and it'll tell you where your vulnerabilities are before you even launch if you want to. So I'm going to let this launch, and I'll show you the UI and where I'm at with it right now. I started learning Java. There are levels to this. Yes. So Java runs in its own virtual environment. That's exactly how I'm building my language model or my programming language. It's going to also run in its own virtual environment, but the virtual environment is going to be different than how Java does it. It's actually going to be a quantum computer. So this tool here is what I'm working on this as well. I have a terminal here, so I can actually run an LLM in here, and the LLM would be able to run the tools that are available to you here. So if I do a new scan, for instance, so I'm gonna use it against its own current self here, and I'm gonna create the scan. Do a quick scan on it. There we go. And then from there, I could go and see exactly if I have any, like where my vulnerabilities are. If I have a repo, it'll show me the repository, what's high, medium, or low. If I have a website, I could actually target the website. Here's the intel for the vulnerability and the sources where it's coming from. So if there's any exploits, so it'll scan for exploits, for URL injection, SQL injections, any proxies, reverse proxies. So this is your proxy lookups here. It'll go through and you can run passive scans against your website, and you'll be able to see if there's any payload injections you could do in like JSON files. Hitting your APIs. When you're done, you'll be able to download and get a full report. So this, like I said, this is an early stage, and I'm still working on this, but this is something I'm going to open source. This is all written in C#. And this is something that if you want to get into, or if you want to incorporate this tool into your vibe coding, I think it's going to be very important to have in there. So, but anyway, I just wanted to show that off, where I'm at with it right now. So I do a lot of vibe coding, a lot of development lately, and I built a whole suite of tools here. So my speech to text, that's right here. I built this. If you guys are interested in it, I'll give you guys the website here. And the other tool is my my agentic development environment. That's this tool here. This is what I'm using, and you can bring your own AI. So like if you have Claude, OpenAI, Gemini, OpenCode, what's neat about OpenCode, if you like DeepSeek, for instance, DeepSeek is a lot cheaper cost than all these other ones, and they're just as good as open code and Claude. And you run that inside of open code. So you can run open code here. Kimi, I can't even pronounce that. I can't even say gargoyle, and then Grok. So yeah, I mean, it's a pretty neat ADE. Ask, what's your problem that your language will solve? What's my problem that my language will not solve any problem? So what I'm hoping it'll do, this is my main goal, is because it's going to be built on a quantum computer virtual machine, I'm hoping it can run algorithms at 10 times the speed than your normal CPU or GPU can. So when you're building your application, I want it to be able to be a lightweight code it's a lightweight programming language and it's a low-level language that's as powerful as C# and Java and Rust, that it can run 10 times faster because it's in a quantum virtual machine. I'm not trying to solve a problem. I am doing this so I can learn how programming languages are built. And while I'm doing this, I'm going to go ahead and do something that's a little bit different and hasn't been done yet. There is quantum virtual machines out there. There's a whole list of them. In fact, I have them here. So if I go here, yeah, so here's some right here, some of the top ones. And none of these are doing what I want to do with mine. And I did a full research, full comparison with these. So, and a lot of these are designed to write to quantum programming language, right? So like the Q# here, you have to already have a quantum chip just to even run this one. This is closer to what I'm doing, which, Microsoft QIR, which is low language virtual machine, or the low language quantum virtual machine is the Rigetti. But they are based on binary. So they are only building these three parts right here. That's it. I am going to be building a stack that sits on top of my own virtual machine. So, and that part hasn't been done yet, and that's what I'm doing. As you work in batch data, way to the speed sent that critical, hence never learn C#. Okay. I'm learning as I go too. So they're all on idle. Okay, everyone's on idle. Is this a good stopping point for us to test the new speeds and get a benchmark? I need to benchmark it from the LLQVM, and I need to benchmark it against the native CPU and GPU and see what the difference is in speeds against a complicated algorithm. So right now, I prototyped it in Python and my VM, and I was able to get it like super speeds up to there's one point I was able to get it like 3,500 times faster than what my GPU or CPU could do. But right now I'm rebuilding it in Rust, and I'm trying to get the same benchmark as I was getting in Python. So, I mean, that's incredible. If I'm able to get those type of speeds, and then I'll be able to start developing apps that run that much faster because it's running inside of a quantum computer. So I wonder, it doesn't look like we're done with the GPU implementation. And those are my core functions for my my hardware the hardware that's going to be connecting to is I'm going to have a CPU, GPU, WSMA, and if there is real quantum hardware in the future that you can still run this on. And I want to get to the point where we can even run this on like a Raspberry Pi or Linux or Mac or any type of hardware out there. That's why I wanted to build it on a virtual machine, so I could touch those different architectures. Short answer, good for benchmark snapshot, not yet final CPU, GPU claim. Oh, there he goes. Okay, he's sending work to all of them right now. Good. Is your backend and Fast API or Django or Java? My backend is going to be Rust right now. And then after I build it in Rust, that's what the low-level QVM is going to be. It's going to be built in Rust. And then after that, when I build my own language, I'm going to rebuild my virtual machine in my own language. That's sort of how Rust started. If you actually look at Rust here, let's see here. What language was Rust built on? And I think it's like QM. Yeah, okay, OCaml, that's it. So Rust started out with OCam here is what they started with. So during the early years, the Rust compiler was written in about 38,000 lines of OCaml. Early Rust contained several features no longer present today because now they build Rust on with Rust. How is Rust built in Rust? Yeah. So, and right now I'm building mine in Rust, and then when I get to the point where I can actually build my own compiler and my own virtual machine, I'm going to build it inside of my own language, and then just build on from there, make it better, stronger. So it's going to be dog fooding itself, which that's exciting. Come on, guys, keep asking questions. That's what I'm here for. Or we're going to sit here and quiet listen to music and stare at a screen that's just moving a bunch of text. And that's boring. See, when I'm vibe coding and I'm not live streaming, instead of talking to you guys, I'll be sitting here either watching a movie or YouTube or reading, just learning more. But I would rather sit here and have a conversation with all of you. I think that's more engaging. I learn more from you guys than I do from reading online. Use that source of truth benchmark. Okay, so what are we at? Does that now read the handoff route? Okay. I hope we're at a faster rate. I'll show you the rates I was getting earlier. Oh, it's incredible. It's way up here though. So this is when I was prototyping in Python though. So that's not a good fair assessment. But it'll give you an idea of my where I'm going to be going with this. Yeah, so when I was doing sparse entanglement chain, I was getting 3,523 times the speed in my GPU. So I was tearing it up. These are my different benchmarks I was doing in Python here. So, yeah, so I mean, look at this. 35,000 times the speed in sparse entanglement. And then the hard-marred growth, I was getting 448 times the speed. And, of course, these are my algorithms that I was running against it. So, and plus, I was running slow here. The Oracle search, R64, I was actually slower. And the plain search, I was slower. So those are the things I wanted to focus on after that. And after I started fine-tuning it, I was actually getting faster on my search. And, yeah, right here. So my search versus the GPU brute force on the native. So on there, it was getting 0.02 seconds for the native, and my VM was getting 0.004 seconds, which is freaking so much faster. So yeah, 4.75 times faster. So yeah, I was screaming, getting some incredible speeds in just my virtual machine. Doing these, there's 4 different algorithms I was testing against. I'm hoping to get even faster using Rust. So LLM Ops, ML Ops, Gen AI, Agentic AI, Cloud Administration. That's your learning stack for the next 6 months. If you have any questions about LLM, I built my own LLMs. I have lots of them. So if you have any questions on it, I can tell you about any and all architecture and how they function, how they work. I have a whole list of LLMs here. Let me find them here. In fact, I was working on one. I actually, it's funny because when I was building my quantum virtual machine, I'm like, I want to put an LLM inside of it, and I did. I did that today. One that I was working on. So if I go to projects here, I got one. I got a couple of them here. So my Plyrium Cortex here. This is an LLM that I was working on here. I was trying to, see, I got a bunch of experiments here. I was trying to redesign some of the aspects of the transformer. But if I come here, I even got to the point where I was creating actual real physical neurons like a human brain has. I have each one of my neurons, my cells, can range from 96 to 145 compartments in the actual neuron, and it branches out like a real tree. And there's several different compartments inside the actual neuron. It's so cool. It's just slow as hell. But that one neuron it's like a computer built inside of it. I would love to run that in my quantum computer. I think that would be cool. Let's see here. Yeah, these are all different, like in my S2 LLMs. The one that I really am proud of is my HSRM. Let me find it here. Oh, here, let me jump in here real fast. I want to show you guys something. Source. That's not in source. Where's it at? Oh, temporal field. Then paper. Yep, here we go. So just to let you know, give you an idea of my education, I actually have published scientific paperwork. I'm self-published, or an independent researcher. And here is one of my scientific papers. This is based on my, I had a question. My question was, does time have a physical geometry? And I started doing math on it, and while I was doing some math, I actually went deeper than I ever expected. And this is my algorithm here that I came up with, and I actually found a harmonic wave. There's a 2F, which is a disformal, and a 1F, which is a formal harmonic wave, and they're synchronized with each other. That is actually out there in space right now. And the 2F signature is my time, and it's actually dark energy that I've discovered. For me to prove it, they have to run it on this algorithm on an atomic clock. This is pretty much the fingerprint. So if it exists in nature, this is the fingerprint on, it'll tell them exactly where to find it. But with all my research and everything that I found and all the data out there, so far it does exist. So, and this is my, this is the harmonic wave. The red here is the 2F. So for every 2 heartbeats, the 1F has a single heartbeat. But it's so synchronized on how it works. And this is the power spectrum here. And it's sitting up there at like the, what frequency is it sitting at? Like 45 or 48K, I think, is the frequency. Yeah, 10 to the power of 48 is what it is the frequency that it sits at. And these are different experiments that I've ran on it, but this is the actual disformal 2F channel right here. And it'll actually tell you like the different frequencies. You can find out what hertz. So anyways, what's up? Yeah, so this is my scientific paper that I've written. and I publish this. Oh, my LLMs, I'm going back to that. Sorry about that. I just ran into that. I'm like, oh yeah. My HSRA. Yeah, here it is, or HRSA. So this is a different attention layer. So I kind of redesigned the attention in the transformer. So what I did, I built a highway. So the way a transformer works, it has layers. That's your depth, right? You have an attention normal, and your decoder. And then each layer is stacked like that, right? And then your attention layer, it feeds forward, and then your back propagation comes back. And with your back propagation, if you're too deep but not wide enough, you would actually start losing some of the, I forgot what it's called, the gradient. You'll lose some of the gradient, and they can't adjust to certain knobs. By the time it gets back, it loses the gradient, like the energy. So I built a little highway that connects to each one, the depth, so you can go as deep as you want, and the gradient flows on that highway, and it interjects to each layer on the side, is how I built it. I built this last year, and of course, let's see here. Yeah, so I built this last year when I started on it, and now DeepSeek has something similar to this. It's pretty cool. So, anyways, I just want to show that, show that off. All right, where are we at here? Okay, do we have speed comparisons yet? What's up, Shoy? What's up, Saj? You're super new. What's this? I am building my own programming language from scratch. Just started today. So I've never done this. I don't know anything about building your own programming language, so I'm learning here. So that's the speeds I wanted to see right there. Where the hell's my mouse? There it is. So my sparse chain, the Q12, look at those freaking speeds. It can do sparse chains, and that's almost like 50,000 times what a CPU would do. Yeah, this shows sparse LLQVM dramatically faster than it. Yeah. Let's see here. So percentage-wise, what's the speed difference between the CPU? So I got the sparse, the dense, and I also want the search. Also, the four, I want the sparse, the dense, and the search is the other type of algorithms I want ran on it. Yeah, 4,000 times faster. That's freaking amazing. And then 32.6 times faster for the H12. And the sparse chain on the versus the sparse H2 is 131 times faster. That's insane. That's what my virtual environment's doing on my computer. It's faster than my native computer. And I want to build a programming language on top of that. Imagine how fast your programs are going to run now. That's what I'm hoping for. I'm excited. Awesome. Okay. Are we still working on the LLQVM? What is left that needs to be done with it? Yeah, it's not even done yet. And I really think we can even get it faster than that. I'm hoping I can get it faster than that. Okay, looks like the entire team's idle right now. Let's go ahead and get the rest of those finished, and we can start moving on to the compiler or the assembler. Tree hygiene point out in the book. Enterprise care about latency. Researchers care about throughput. Chi Hygiene pointed out in the book. Enterprise, I don't understand what you're saying there. I'm missing the context, I guess. So if you guys want to see what the flow is going to look like here with my programming language, let me bring it down here. So right now I am working on the LLQVM, which stands for Low Level Quantum Virtual Machine. I'm working on the bytecode, the runtime, and the backend adapters. Once this is built, this is all going to be built in Rust. Once this is built, I'm going to be able to build the source code, the parser, and the source, which the source and the type is going to be one system here, and the parser is going to be its own system, and then we got the PlyQ source code. Once I'm able to build the source code, like the actual programming language for my new program, I'm going to be able to rebuild the LLQVM with my own programming language. So I'm going to eliminate Rust from the picture, and then I'm going to be able to use it to build itself, and then make it powerful, add new features to it, make it stronger, and turn it into an actual real programming language. So I'm excited. This is so cool. I'm excited for this. Oh, I want to look at the other documents here too. So the language model, this right here is how we're going to do the language model. In fact, that reminds me here. Give me a second. Yeah, especially get the writer, start writing out how the language is going to be written, and also we might want to go ahead and start working on like a PRD for the project ready document on this, and get the full architect document based off the PRD. So let's get the writer to start working on that. What's up?
Is there anything
Huh?
that you need from Walmart?
What's that?
Is there anything that you need from Walmart?
No.
No?
Who are you talking to?
Mom? You didn't answer with your phone.
Did she? Where's my phone? It's in my pocket.
You said really?
No, I'm good.
You said no. I'm good. Oh, chips. We need more chips.
Need more chips?
Like the ones that we had.
Yep.
Oh.
I'll be right back, guys. All right, I'm back. Sorry about that. So what I miss? Well, they're still grinding, aren't they? Let them grind. Get some music going. Do you guys drink Monsters? This one's zero sugar. I don't drink anything with sugar in it. Stay away from that. I'm already fat enough. I also want you to think of ways that can make our LLQVM even faster. In fact, there's several already out there, and I want you to take the best out of all of them and see what they're doing, and we're going to learn from what they've done right to make it even faster for ours. I only got, oh shoot. We got 3% left. Oh, we might be calling this short, guys. I didn't realize I was using that much. Holy crap.
Christina Thomas, my sexy wife.
Hello. Oh, are they? Okay. All right. Well, I tried building I built lots of LLMs. I actually have a whole list of them, of different models, different types, prototypes. Built them from the transformers, my own transformers that I built. Um, so yeah, I have lots of them. But I'm not building an LLM right now. What I'm building is a programming language. So yeah, I'm building my own programming language from the ground up. And it's going to be like Java, C Sharp, Rust. It's a low-level language, and instead of a like they all like Rust and Java and even React, they all have a virtual environment that they run their binary code in. Mine is going to be, I am also going to have a virtual environment, but it's going to be a quantum computer. And that's what I'm building right now. It's a virtual quantum computer. And it runs so much faster inside the quantum computer. And I'm going to build my language on top of that. And now I'm going to rebuild all these apps that I have, like my Plyrium Forge. I'm going to rebuild that with my own language, with my own programming language. And my speech to text that I have here. I'm also wanting to build my own LLMs using the quantum computer virtual environment. So this is my speech to text program that I built here. And this is locally. It doesn't connect to any server at all. I could be off the internet and still use my text to speech. Like Windows, they have one. If you hit Windows key and the H, here, this is the Windows version here. The problem is anything you say gets captured and gets sent to Microsoft. And so here, I'm capturing everything I say, but it's stored locally on your computer. It does not get sent to any server. You can clear it all. You could actually click these to copy it. This is everything I've said, and it records it daily. Like this is all this morning. So starting yesterday. So this is everything yesterday. You know, it records everything. And imagine the ones you're using that are connected to other people's servers. Who knows what they're capturing and using that data for? So let me get this straight. Since everyone can't buy data, we all simulate an algorithm to reproduce data for us without actually buying the data, right? Sure. I mean, all data is simulated. So that kind of threw your theory out. Since anyone can't buy data, you can buy data. You can purchase it. It's a virtual thing. You don't really own it. You just buy it. Like if I sell you, like if I buy, you know, a list of email addresses, that's data, and I bought it. I don't actually physically hold it, but it's data that I bought. We all simulate an algorithm to reproduce data. Yes, so every human out there who either has one of these or Microsoft or any type of other thing that you're simulating data on it. Even if you have Alexa or Google or whatever in your home, it's going to be simulating your data for you. And then they're going to sell your simulated data. Yep, I hit my usage limit, damn it. That's the first time I've done that in so long. I was grinding hard today. I'm at 0%, resets at 12:36. It'll actually reset sooner than that. I think it's actually 10:36 is the time it'll reset. So I'll wait here for a few minutes. I could always upgrade my subscription. I only got the $100 subscription. That's what I usually code with now. Let's see here. Can't tell if I'm logged in or not. Yeah, codecs, here we go. And the hell is it? Yeah, here we go. That's what I wanted to see. Huh, I used a 5.3 Spark. That's not what I wanted. Have to restart this now? Or am I good? Yeah, I'm good now. Up yours. Screw you. I've not made the program language yet. I'm working on the virtual, the low-level quantum virtual machine right now. So the architecture, let me show you the architecture here. Let me go to here. So this is the flow, right? So right now I'm working on the LLQVM, the bytecode, the runtime, and the adapters. This is what I'm building. In fact, it's already running. I'm just kind of improving it right now. And then after that's done, I'm going to build the actual source code, the parser, and the source, and the type PlyQ or the IR. Okay, go ahead and continue and get everybody else continued. We had a stoppage there for a second. Okay. Have you settled on syntax style yet? I have not settled on any syntax style yet. I am going to include object-oriented style. However, it's not going to be the main focus. I actually like how Rust does it, where they use the modular and the component style. I want to adapt that to it. But the syntax style, I actually, if I can do it, I may want to do it like how, I want it as plain English as possible. I wanted a very easy readable code. So I don't want it complicated or hard to read, like how Rust is. Rust is such a pain to read. And that's what's funny because I'm writing this in Rust. Let me show you here. If you have ideas, I'm all for it. If you guys want to share your ideas with me. So if I go to the LLQVM here, come on, source, and let me look at the back end here. So to me, like these are all just a bunch of functions, but to me, like this is stupid and hard to read. It just looks like a bunch of like verbose crap, a wall of text. I don't want mine to look like this. I really don't. I want a clean, easy readable language. Yeah, see, I like Python. I actually enjoy how Python's written, and I might actually do something similar to that. I don't mind the brackets and stuff. That I don't mind. But I want the language to be very easy readable language. By the way, I was doing some speed tests with my VM, my quantum computer virtual environment, and I was running some heavy algorithms in it. And some of the algorithms I was running compared to my natural computer, the hardware, my VM was getting like almost 30,000 times more computational speed versus my native already. So do you have an idea what our syntax is going to look like, or is this something we're going to discuss? Because it's going to be important on how we're going to build our syntax in our language. Let's see what our director says here. And we're going to have that discussion. Visual Basic, I can't stand Visual Basic. VB, ugh. That's a dirty code, man. I'm gonna give you heat for that. Now, PHP is also one of those ones. Like, it's got like all the question marks, and it's got so many different keys that it's not needed. It's just so nasty. Well, what algorithms were you running? I was running here, let me show you the algorithms I was running. Hang on, I'll let him tell you after I'm done. For our speed test, what algorithms were we running? So for low-level assembly, I'd keep it simple and close to LLQVM. No, we're not going to do that. And by the way, no, we're not going to do that for low-level assembly. We're not building low-level assembly. We are going to make it more like how Python syntax is. Because this is going to be more than the low-level assembly. This is going to be a full programming language. Also, what other algorithms we're running for the speed test? All right, let that finish. And while that's going, I actually have it here as well. Because I was prototyping it in my Python first to see how well I can get it. And I'll show you the different algorithms I was running. So one of them was like a sparse. One was a search, like a lookup. Hang on. And I'll show you the different speeds I was getting versus each one, just in the Python. But my, so far Rust is already beating the Python. So right here, okay, so I was running compile Oracle, the R64, the X8, so 8 times R64, and the N X times 64. These are the speeds I was getting versus my native GPU, which is 2 times faster, 1.5 times faster, 1.2 times faster. And then I was also running, so this is the search, because before, I couldn't beat the native search until I made some adjustments. And I was actually beating the search after I made the adjustments. So the native was doing a brute force, and I was doing a compile online search. And I was getting 4.75 times faster speeds. And then here, when I was doing entangled chain, I was getting 35,000 or 3,500 times the speed. And I was actually able to get, let me find it here. Right here, for sparse entanglement chain, I was getting 35,000 times the speed versus what my native was getting. But this is where I was losing on search until I made my adjustments. So now I'm able to beat all of these. These are the different algorithms I was running. So I got the growth H12, I got the search R64, and I got the plain search. And then, of course, the entangle speed. So to give you an idea of what algorithms I was running. And then in Rust, I was running, let's see if this is going to tell me here. Let it get through all the spam. VibeSync Academy 2026 developed sticky noted size screen for users to place thumb on to record brain activity before and after a trick shot. Results out of sync. Okay. I'll need dev for PHP 8.5. It's very clean. You can obviously still write shit code, but if you keep your standards up, it's nice. Yeah. I used to write PHP. I hated PHP. And I didn't write it professionally. I just did it just to learn how to write it and wrote some web applications with it. And I hated it. And right now, what they're doing right now, he's assigning these ticket jobs here. These are all tickets. He's assigning it to the team here. Oh, okay. I never did get an answer. What type of algorithms were we running, and what were the speeds against the native GPU and CPU? But 2000 was the Wild West. Yes, it was. And that's why I try to explain to people. So I grew up in the early 90s, of course, and late 90s. And I was around when the internet and computers was actually starting to become popular. But it was still the Wild West then, like you were saying. Even the internet, it was just the Wild West. So everything was brand new. People were trying different programming language. And, but a lot of people who actually got into it knew what they were doing then. A lot of them are millionaires and billionaires today. Then after that, the next big thing was Bitcoin and cryptocurrency. And a lot of people who knew what they were doing with that are millionaires and billionaires today. But people laughed at them like, hey, that's not going to go anywhere. It's not going to do anything. And by the way, here's my speeds right here. Yeah, so I was doing sparse chain, dense chain, and sparse H12 for Rust. And these are my speeds I was getting here. So benchmark algorithms are right here. So, but anyways, and so, I mean, look at where Bitcoin's at today in crypto. It's not the Wild West anymore. I mean, it kind of still is. There's a lot of bad ones out there. You just got to be careful, know what you're doing. But the ones who did get into it early, I mean, they're doing great. Same thing with the internet. The ones who got into it early. Well, right now it's AI. AI is the next Wild West. This is your chance to get into it, to develop in it, to learn it, to grow your skills in it, to use it to build automation tools. Hell, I'm building a brand new programming language, and maybe I may include AI into it. I don't know yet. That would be so awesome. Programming language that has AI built into it. That would be freaking amazing. The people who get into it now, what's it going to look like in another 10 years, 15 years from today? And the people who are just now starting off an AI, then they're not going to be able to be at where we're at today. So that's the way I look at it. So what was those are the speeds, but what was the actual comparison percentage wise? So sparse chain versus dense chain. So no, I'm talking about no, not against each other. So I'm talking about what is the speed difference between native hardware versus the low-level QVM hardware? You need help? Did you say yes? Okay. I'll be right back.
Rebecca?
All right, I'm back. Yeah, let's see if we can get a comparison with the actual native hardware versus the LLQVM. That's the important test. That's the speed difference. We're going to have to find out what it is. So for your AI usage tip, go to Google AI Studios, make 10 projects, make one free API key per project. Oh yeah, those look good. Let's see here. You now have 10 daily usage buckets for Gemini, or Gemini embedding, live API, voice, etc. Enjoy. That's cool. Google AI API usage is per project and not per account. Okay. At some point, I know you could actually run GPU power inside of the Google project, so you could actually train LLMs inside of the Google projects, which is pretty cool. I do know that. At some point, you'll have a large push towards local LLMs for programming, I think as energy cost rises globally. See, I would love to be able to build my own LLM on my own language. That's actually not the results I was looking for. Hey, stop that. I want to see that. So large providers are operating at a loss, which is fine, while the industry develops. Yeah, and that's common. That's gonna happen. But right now they're too big to fail anyways. They'll get bailed out or something. And deals are gonna be made. They're gonna have to figure out how to make things cheaper. That's what I love about the free market is the innovation. And they're gonna be able to make it where these LLMs are going to be so small and cost efficient, but have the same power, if not stronger, than what we have today. That's the point where we're going to get into the future. Bro, what are you even doing? It looks cool. I'm actually building my own programming language. And the tool I'm using, I built this tool here. It's Plyrium Forge, and it's my agentic development environment. I can run my AI in here. It's an orchestration AI. So I talked to my director, which is the big terminal here. And my director will communicate to the rest of my team. Like I have a coder, an auditor, another coder, an architect, a writer, and a quality assurance. So he'll delegate tasks to the team to get things done. Quarterly on credit. Bro, what are you, okay, yeah. All right. Okay, I missed that. What was the speed difference? It looked like that the LLQVM was slower. And if that's the case, we have to make some changes before we move forward because we need that to be faster. I had it faster in Python, so we have to do something to make it faster. Yeah, 13 times slower, 100 times slower. Yeah, these are not right. GPU, no comparison yet. GPU rows. Yeah, so in Python, I compared it with a GPU and CPU, and I was so much faster on the Python. So, and I told you, I have all the Python scripts. You're supposed to look at that. And also, you're supposed to look online at the actual LLQVMs that are out there right now and see what they're doing right and see. Are you serious, you freaking narrator? Okay, so this is what's neat about my speech to text. So I lost the window there, the focus, so it won't be able to go in there. But I come in here, I click on that and copy that, so I don't have to repeat what I just said. Yeah, so I have my own speech to text here. This tool here, I built this too. So this right here is my speech to text. And this is running on, there. I have, you could choose between a large, medium, or small text-to-speech LLM. This runs locally on your computer. So the small will run on your CPU, and the large, it'll run on your GPU. This whole thing here is designed to be able to run offline and on your computer, no matter what your hardware is. So if you need a tool that can do speech to text like I do here, I talk to my guys here. Hang on here. Yeah, so that gap we need to close, and we need to be able to make sure that our quantum virtual machine is much faster than native GPU and CPU. That is the whole point of what we're building here. If we can't get it faster, then there's no point in even using the quantum virtual environment. And I have a 16 gig 5080, I think, GPU. Yeah, 5080 GPU. And 16 gigabytes, yeah. And I've ran like a 20 billion model on mine. Yeah, and you're right, you have to quantize the heck out of it. And then lower your context window like tremendously. So, but a good comfortable one, I could run the 7-8 billion model on mine comfortably and have a decent sized context window, like 10,000, 20,000 size context window. So my new project, Johnny, I know I'm all over the place. How you doing? Welcome to the stream, by the way. You're a little late, but I am building my own programming language. And how I'm going to do it is, so Java has their own virtual environment, their environment that they run in. That way they can run it on any hardware. Same thing with Rust. Rust has their own virtual environment that runs, and same thing as React. React has their own virtual environment. So the hey Hans, the my programming language, I also have my own virtual environment that I'm building, but the difference is mine's going to be a quantum computer virtual environment instead of a regular bitwise type computer, or like an x86 or 64-bit computer. So I'm building an actual quantum computer, and it's a low-level quantum virtual machine. You said the key technical path LLQVMs cannot execute sparse workloads through a generic VM loop and execute or expect to beat native CPU GPU. But I did that already, and I did that with Python, and I showed you the code on it, and I've already beat the CPU and GPU. Yeah, I'm hoping to think ahead here, and if I get this to where I want it, I am going to actually rebuild Plyrium Forge in my new programming language. You're right, I should have been more precise. The correct framing is your Python prototype did beat CPU GPU for the workload you tested. The current you stop that. I'm trying to read. I'm new on your stream. What are you doing? I am building my own programming language from scratch. It just started today. Do we need another one? No. Do I have a reason for it? No. I just want to do it. I'm learning from it. And I have a cool concept that I want to try. So I'm actually, if you're familiar with quantum computers and how they function, they're way different than our normal computers. But I was able to build a virtual quantum computer inside my computer, and it was able to run faster than my native CPU and GPU. So because of that, I want to build a programming language that runs inside of it. Okay, I missed everything you just said there. Can you repeat that? Yeah, okay, I got all that. We already talked about that, but like I said, I was able to get Python to run faster than my CPU and GPU running different algorithms, the same algorithms you're doing and more. So how do we get Rust to be able to do the same thing, if not faster? What is that gap that we need to close?
Yeah, my bad. I put that there. I didn't know it was here.
The gap is not Rust, it's slower than Python. The gap is that current Rust LLQVM is doing more general VM work than the Python prototype was doing. But it's not doing more work than the prototype was doing. Like I said, look at the code. I have the Python code, and I also showed you the algorithms I was running. What makes you think that the LLQVM is doing more work? Yeah. You think I was talking to you?
No, I thought you were talking about person.
Oh, yeah, I'm streaming. I mean, there's people here.
Oh, okay.
Oh, that's great, but just one question. how your virtual quantum computer works faster than your CPU and GPU if you are running it on your native computer. It's how it calculates the algorithm. So the way a quantum computer works is a regular computer, they have 2 bits. You got on and off, 1 or 0. And that's for all their calculations. A quantum computer has both states, on, off, and they're always true or not true until you observe it. You don't know what it's going to be. So it technically has 3 states to it. And it can run, when it's doing algorithms, it can run faster algorithms based on the qubits is what it's called. And the state it's in. Think of it like quantum physics. That's exactly how it's defined. Like for all possibilities exist in multiple dimensions type thing because there's multiple possibilities. So a quantum computer kind of works that way based off the qubits. So instead of being on or off, like yes or no, it's always yes, it's always no, and it's always both at the same time. It's all the answers at the same time. So it calculates different. Hey, Zach, I am building my own programming language. So let's see what it says. You're right to push that. Now that the Python recovery card is back, the evidence is clear. Python sparse wins were mainly sparse detection active state workloads versus dense state vector quantum VM. Python costly Oracle wins. More mainly compiled Oracle cache set up online. Amortization with repeated cache online. Runs compared against brute force GPU. Yes, that's what I was doing. Current Rust bench sparse compared LLQVM sparse against stronger direct native CPU shortcuts, direct basis propagation, active state count. So Rust being slower on ratio versus native CPU is not the same comparison as you, okay. All right. Okay, there's got to be a way to make it faster though. There is other virtual quantum computers out there right now. I could give you the list if you're not familiar with it, or you could do online research. And a lot of these are open source. We need to see what they're doing different than what we're doing. And some of those are actually low-level quantum virtual machines. So we need to see what they're doing different compared to what we're doing and how we can implement ours in a way where it does calculate the qubits faster. So, Zach, I am building my own programming language based on sort of like Java and Rust. Both of them run a low-level language, or not language, low-level virtual environment. And that way they can run it on multiple different hardware and machines. I am doing the same thing, but mine is going to be a quantum computer VM. Do you use any AI help for building this? That's in front of your screen right now. Everything, all the text, every single one of those terminals is AI. I have 1, 2, 3, 4, 5, 6. I have 7 AIs running right now doing this. That's what my tool is. They're orchestrating together to build this. Think of it like a team. I have a whole team of developers that are working on this. I have 2 coders, 1 auditor, 1 architect. I have a writer, and I have a quality assurance on my team. So search Project Q, high performance, quantum simulator, C++ gate fusion. And I was curious if I should have written this in C++ instead of Rust. I still may do that. Just until I get the my virtual environment built the way I want it, then I could build my programming language on top of that, my own language, my syntax, and then I'll be able to rewrite my virtual computation or my virtual quantum computer, virtual machine in my own language. So you assign it to the architect, and the architect is working. There he goes. Okay. And let's see what he's actually going to be focusing on here. So Clayman run card, so that's the card. So his job is to run this card right here. This is what the architect's working on. So director source scan, Rigetti QVM is a high performance QVM for quit QSIM, uses C++, AVEX FMA, OpenMP, Gate Fusion, and QSIM. Okay. Move to do in progress. Yeah, okay. So my architect is doing the research right now. What techs use? So my tech stack right now is just Rust, currently for my language, my programming language. And once I build the low-level part of it, I'll be able to rebuild it in my own language. That's where I'm hoping to get to. And I'll show you what the what's going to look like here. Hang on here. Huh? Did I not grab the... Nope, I got to scroll like this. Give me a second here. It's a mile down. Oh my gosh, come on. Okay, so here is my flow, how the programming language is going to work. Right now, I am building these three parts right now, the LLQVM, which stands for Low Level Quantum Virtual Machine. And I have the bytecode and the runtime. And of course, the backend adapter is built into it. The backend adapter is what makes this virtual environment run on your computer. It'll connect to the CPU, GPU, and whatever other type of processor you have in there, or even a real quantum hardware adapter. And that's the whole point of this. The top half of this is going to be the source code. That's going to be my syntax, the part that you write, and then you got the parser and then the compiler that's going to be compiled into the bytecode for the LLQVM. So this part's going to be written in Rust. And then after I build my own programming language, I'm going to use my programming language to rewrite the LLQVM, the bytecode here, and the runtime. So it'll be 100% self-writing its own programming language. How did you get do that to get them to work together? I built that tool. So this tool here, this is my agentic development tool. So the way they talk to each other, there's think of it like they all have their own telephone or their Teams chat or whatever, like their own Discord. And there's communication that's happened between all of them. So when I go to, let me open it up here. So my topology here, the director's in the middle, and you see these wires connected to these bubbles outside? All the bubbles outside is my team. And that's the communication link between each one. So if the auditor wants to send information, if you watch this long enough, when they start communicating, you'll visually see it here in a second. And they'll start talking to each other. I'm scared Codex just changed 100 files in my project. Oh, well, be careful with that. That's why I use Git, if you can, and build work trees. So when they do mess up, you can always revert back. So you're going to do bootstrapping for this? I'm not familiar with what you mean by that. Am I going to do bootstrapping for this? Okay, so the communication's happening. You'll start to see them work with each. You'll see in the middle here the actual communication, and they're reporting back to the director. And there it goes. So the architect one is sending information back to the director. This is, think of it like like it made a telephone call, like, hey, here's my data, and it hung up. Boom, we're done. So that link is closed now. The only link that's open right now. So the director's making a call to the coder too, but hey, I got work for you, and it's going to create that link and make a connection. So you can visually see them talking to each other like this. Yeah, I'll show it to you. Hang on here. So this is my text to speech. It works offline. It'll load on your computer. There's a CPU and a GPU model you can run, either one. But yeah, if you go there, you guys can actually, this is the tool, Plyrium Forge. If you guys are interested in it, but that's what I run. And if you didn't notice here, I actually have token efficiency savings up here. So right now I'm saving up to 47% token efficiency on all my agents here. 46% now, but you know, that's what's neat about mine versus everybody else's out there. I have tools built into each part of these terminals that'll strip out unneeded tokens that's being sent. So you're not being, they're not calculating those token costs towards you. It's like building your programming language compiler with your own programming language. I also don't know much. I have heard it theoretically only. Yes, so that's exactly what I'll be doing. Rust does that now. So, and so does Java. Java uses Java to build Java. But so here's Rust. So Rust was originally built with only 38,000 lines of code on a programming language called OCaml. OCaml's a programming language. And so now this is what they built Rust originally on. But now Rust builds on top of Rust now. Rust uses Rust to build Rust. But when they first started, you had to start somewhere. You had to start with a programming language somewhere. In my case, I'm starting with Rust. So the open source QVM comparison is in testing and now routed for audit. Needs internal execution plan, prepared programming, okay. It needs cache keys and setup versus online reporting. It needs Fusion, SM, and threading GPU only after the planner. Okay, I created. All right, so did the architect get back to you with data on his research and findings on how to make ours equivalent or better for faster speeds versus the native? I'm new here. Have you worked in tech before? What are your pre-AI experiences? My pre-AI experiences, I'm actually a Microsoft, I'm an architect for, I'm a Microsoft 365 architect, and I work for a large company, and I manage their entire cloud infrastructure for Microsoft. So that's what I do for a living. I've been doing that for about 20 years now. Can we make games using? Yes, that's the whole. That's one of the big things I wanted. I wanted this to be able. I want to get to the point where you could actually build your own operating systems. I want it to where you can build your own game engines, your own games, your own desktops, your desktop tools, even to the point where you can even use build websites with it. I would love to have a tool that could do all that. But it's going to be a long ways before it gets to that point. Right now, we need to get to the point where I can actually build the basics of my assembly language, and that's the low-level part of it. And then when I get to my syntax, my main language, that can, and then I have my converter, which will convert it to bytecode, down to my virtual machine. That part there, when I get to that point, I'll be able to build onto my own programming language and go from there. And I'm documenting every part of this, so anybody who runs it can understand how to write in the code and everything. And I want to try to keep it the syntax in English like Python is. How you doing, Shin? Hey, KLG. So how much time do you need to make this as a final version? I have no idea. This is my first time ever creating my own programming language. I could not tell you how long it normally takes someone to do that. But if I could get the basics going where I can start developing in it and compiling my own programs, I think that would be the first milestone. And honestly, we could probably get that done this weekend, I'm hoping. Can you imagine making something like this? Definitely a piece of art. Well, thank you. I think you could. I really do. I think you could. I think anybody could do this. I'm definitely not a software engineer. I'm not a UI developer. I'm not good at any of this stuff. I don't know. I just learn how to do it and go from there. So execution plan selector design is now routed to QA. What it covers. Okay, this design. Okay, but you never did tell me. Okay, I must have missed it, but what did the architect come back to you with on our LLQVM versus the native CPU? Oh, they did it again. I hate that. Okay. Imagine how they first made the first programming language? Heroes? Yeah. I actually worked with someone who worked in the 70s and 80s, and they actually wrote programming languages using punch cards. These cards had holes in it, and these holes are what the data was. That's the program. And they would run these punch cards, and they developed new punch cards for their program. And that was the original. So it was just bytecode or assembly code. And then from there, they went to assembly code. And just kept getting better and better after that. So I'm chatting with a man of future. I guess I can call you like that. Okay, yeah. Thank you. Bro, do you have programming? I do not have a programming background other than my own self-learned experience on programming and developing. I don't do it for a living. I do it as a hobby. Okay. We're already faster than native CPU in online sparse execution, but not in the end. The remaining gap is setup overhead. We're getting there, guys. We're getting faster. The actual online sparse calculation is now faster, but setup cost is still too high. Validation, analysis, planning, allocation, reporting. Okay, those are the setup cost is still too high. The validation, analysis, planning, allocation, reporting. We definitely need to get those sped up, and we need those faster than the CPU and the GPU. We need to get to the point. I mean, if we can't get any faster than that, we need to. There's no point in even having a virtual machine. We could just run this native, and that would be a lot better. But I didn't want to do that. I wanted to build a quantum computer virtual machine that I could build my own programming language for it, and in it, and be able to operate like Java and React and Rust. So on some parts, we're already faster, which is good. So, by the way, this is your side project, or you are doing it full-time in your own company? It's my side project. In fact, I built, so the tool you see that I'm doing this in, I built that. I built several other tools too, by the way. So the other tool that I built was the tool that I'm talking. It's my speech to text. This is local, offline. It doesn't connect to a server. And this runs locally on my computer. So I built this tool. And I can actually use it to talk to anywhere. Not just here, but I can use it to talk to, like if I'm writing an email or searching something online. It doesn't matter. So I built that. I actually built my own SaaS website here. Let me show you here. So I built my own SaaS website. This right here is, it's a all-in-one suite for companies like plumbers, HVAC, electrical companies, or any of the industries like that. This does your customer handling, invoicing, bookkeeping, it handles everything in your backend, even for marketing. It has an AI receptionist. It has AI automation built into it. But this does everything for these companies. So when they're out there working in the field, a plumber working on your toilet or whatever, this system will handle the back office so you don't have to worry about it. So I built this. I'll show you the pricing on this. So this is what I charge monthly for my services, depending on which tier package you get and what it all includes. This thing does a lot. And this isn't even half of what it does. This is just the major features, but it does a lot more than what you're seeing here. So anyways, yeah, so I got that. My other tools that I built is of course, my Plyrium Forge, you see here. And then my Plyrium Echo, which is my speech to text. Another one that I'm working on is my, let me pull it up here. Here we go. It's called Securium. This is still in an early stage. I'm not done with that. Go ahead and launch the app again. This is really cool. So vibe coders, one of the biggest things that they make a mistake on is their security and how vulnerable they leave their websites or their applications. It's horrible. And a lot of people don't know what to do or how to fix it. And because AI is horrible about leaving these gaps. So I'm building a tool that can scan your website. Think of it like you hire a penetration tester to penetrate or to try testing all the all the exploits on your website, and they're going to try doing everything they can to break in or to hack it or to do whatever just to show you where all your holes are. I'm building a tool that does that for you. And the database it's going to be running on, there's several databases that's going to look up the vulnerability exploits and all the other stuff. You have Metasploit, GitHub database, Microsoft database, and like a CRM, I think it's another one. And in fact, if I go to vulnerability intel here, so yeah, the CISA database is also going to be one of them. But this thing's going to be able to look up exploits, vulnerabilities, any other type of issues out there, and it'll actually list them by date. So if you come in here and do a new scan, you can scan it on your current application, your code base. You can scan it on your website. You can choose the depth, the level you want to scan in. If you have a Git repository, you do have to give it consent. I have a terminal here, so even if you're running AI, you can open up your AI in here. Your AI can run this tool for you, and it can actually help you evaluate any other issues that you're going to be running into. So this is another tool I'm working on, by the way, and this is written in C#. So, but I'm not done with that. That's just a little show and tell there. And of course, I'm creating my own programming language. So just to give you guys a little bit of ideas of the different projects that I've been building. But the kind of testing application already exists, right? Yeah, sure, it does. Yep, there's lots of them. And what mine is going to have AI integrated in it, and there's going to be different. And I'm not selling that one. That's going to be open source, by the way. But there's several different tools out there that does it, like a proxy reverse. You got Fiddler, like a proxy lookup. You have a net scans like Wireshark, but you have several different tools like Q Hydra as another one for application. So you can have the 15 different tools you want, or you can just have the one, which I'm building, which will do all that. So that's the difference. By the way, this is your side project, or okay, I already answered that. All right, so what do we have? This is your first real narrow end-to-end win. Current results, LLQVM cache faster path has elapsed median 1.25 versus native. Yes. That's good for sparse chain, but it should be higher than that. Still slower. Okay. So for the sparse H12, in Python, I was getting like, I think 2.5% speeds faster. And I know for sparse chains, I was getting way more than 1.25%. So we're not quite there yet. And also, we need to validate our search as well. You get it now? That's cool. Yeah. How can I build like this? Like at what thing I have to focus more to have clear vision for projects? How I always start is it always starts with a question or a need. So if you're not sure how to do something, but you have an idea of what the end result looks like or something that you need, start talking to your AI and have that conversation. Talk to it like a human. Go back and forth like it's a friend. But you want it not to agree to everything you say. You want to make sure it pushes back on what you're asking it, what you're telling it. Because you want that critical criticism. Is this idea worth it? Am I spending my time? And then argue with it. Argue your points. Give them your point of view. Have it do research online. Does this tool already exist? What's it like out there? Am I wasting my time? Am I reinventing the wheel? What can I do that's better? Can we take what they've already invented and make that better? Those are different ideas on how to get started. And then when you finally figure out what you want to do and you already know what the end goal looks like, then you start your project. After you got to document it. Your AI has to document everything. You want to start create a PRD, which stands for Product Ready Document. In fact, I don't even know if I have one, which I usually do. Let me check here. I don't have a PRD, but it's good to have a PRD. See, I'm already, you can see I'm documenting everything it goes through. And it's good to document because your AI is going to have something to reference, because if you close your AI out or leave or come back to your project a week later, your AI is going to be dumb and not know where it left off. So document everything, and that way you can pick up where you left off at. That's how I get started. And then from there, it just keeps growing from there. So still not a win, sparse 12. Okay, that's fine. We're close, but we need to make some changes to actually increase it. Like, how many qubits are you running on this? Are you running the 12 qubits or 20 qubits? Because that's going to be important. If he's only running 12 qubits, 20 total, okay. No, that's right. 20 qubits is where you need to be at. So what else are we missing then? What do we need to do to make this run faster? Really telling I'm so inspired by you. I just had a project on web application. Yeah, you could, like my project, my web application here, it's so complex. And this was my first SaaS I've ever built. I never built one before. I didn't even know how to build one. So if I come in here and say, see it running, this is the demo. So as a customer, this is what they would see. So I'm going to try the demo. This is the back end. So let's just say you own a plumbing company. This is your plumbing company. You come in, you're the owner or you're the receptionist, and you want to see, okay, what's on the schedule today? So we're going to look at that. So I can see right now, this is Tucson, Arizona. This is where my office is. I can see all my techs. I got 4 techs that are out there in the field. I'm going to see what my appointments are today. Okay, I got 3 appointments today. I'm going to see, what tech is doing what. I don't have any, so I need to assign their appointments. So I could come in here and edit them and assign the tech to them, which is right here. So John Smith is going to be on that one. And now we got John Smith updated. He's going to be on there. So I could actually select here John Smith, see where he's at. There he is right there. And plus this also has AI built into it, automation. And what's neat about that, and I can see here's John Smith. He's got one scheduled right now, and you can see where it's scheduled. But the AI, I have a thing called smart scheduling. So what's cool about that is, let me go back to my all here. So if you have like, 10 appointments, it'll see exactly where your techs are, and it'll try scheduling your appointments around where your techs are. That way they're not driving from one end of the town to the next for the next job. It'll try grouping the appointments together, and not just for one day, it does it for all the days, like for the whole week's worth. So I actually incorporated smart scheduling into this. I can come in here, I can manage my fleet. If you know, let's just say they have trucks, I could actually see what type of truck I have, the miles, is it in the shop retired, like who's it assigned to. I could actually manage, you know, their skills certificates, any parts. Let's just say, you know, I could manage, see like any parts that are on a truck, what truck has what parts, so I can keep track of that. My pricing book to make it easier when I'm creating invoices, like a standard drain or hot water heater install or faucet fixture. So if I'm in here and doing my invoicing and I create a new invoice, I could come in here and from the pricing book, you know, we know we're doing a standard snake, so it'll fill that out automatically. Here it is. Let me get rid of this one. I didn't ask for that. So there's the price, $16.50. It'll already fill in the taxes, and I could go ahead and pick the customer. I could either search for them or add them from here. So yeah, this does everything. I built this app. I think I started from scratch, and it took me 10 days to get to where this is at. So I'll leave that. Anyways, I'll stop talking about that. I just wanted to share what's capable of vibe coding and what this tool can do for you. That's why you need to have understanding of things. You want from him, since AI can easily bamboozle you and make it work even though it's fake. Yeah, true. Understand. Is that completely built by Vibe? Yes, the whole thing was built by vibe coding. I swear. End to end. I still haven't even looked at the code, except for vulnerability checks. I've done that. And make sure it's very secure. So yes, AI arguing to your point is important because I heard about a guy who thought that they made a new math formula because ChatGPT made him believe it. He did something. Oh, okay. Yeah, you got to make sure that it has true facts whenever, you know. Don't let it be based off its training data. You have it search online for true facts. I could have afforded $70 a month. Can't afford $700 a month. On what though? What do you mean for that? What's up, Jay Yadev? Thank you. All right, where are we? Okay, he's still doing something. Hang on here. Right now, I'm focusing on trying to increase the speed of my quantum computer here. So we're still in progress there. What do we have in testing? Oh, we got so much in testing. Okay. Where did you learn to vibe code like that? What was your roadmap? So I'll be honest with you. This is how I started vibe coding. And anybody can do it this way. When I first started vibe coding, I started building my own LLMs, large language models. In fact, I prototyped them because I wanted to understand how AI works. I wanted to understand what makes them tick. End to end, I didn't understand any of that when I was first starting out. So the best way for me to do that was start building my own and understanding the architecture. So when I'm working, you know, just me and one AI, and I'm like, okay, help me understand the architecture of LLM. Then it'll name out all the parts inside of let's just say a transformer. I'm like, okay, what's inside the transformer? How does that work? Well, you have an attention layer, and then you have a norms layer, and then you have a decoder and an encoder. Well, hold on, what are all those? Let's start with the attention layer. What's that? What's inside that? Oh, that's where a neural network lives. Is that the only place it lives? Oh, no, it's not. It lives in the other ones too. Well, is that where the memory is stored? No, that's where it decides on what to do with your KVQ. Well, what's KVQ? You know, I'm asking these questions like, what are you talking about? KVQ is quality, or it's key value and what was the other one? Key value. So QK, key value and query. That's it. Key value and query. And I'm like, okay, what are those? Well, those are the cache that your tokens are being sent in. On all of these? Well, no, you got your key and your value is one cache, and that gets sent through your dense network. Well, what the heck's a dense network? So these are questions that I was asking. And when I finally it clicked it, I finally understand, like, oh my gosh, it makes sense now. Now I understand exactly end to end how an LLM works. And I vibe coded my own LLMs, and I wanted to train my own. And I made these small little prototypes, and they could probably do math, like 1 + 2. Hey, it worked though. They were actually learning. So, and then from there, I'm like, we can do something with this, and that's how I started. Is that? You're a great bro. Now I'm going to leave. It's my study time. We'll join it next stream if possible. Yeah, I'll be streaming tomorrow too. So, and good luck with your studies. Yeah, in fact, you don't have to buy a sub with any model. There's a bunch of free ones out there, like OpenCode. They have one, there's a lot of free ones on there, but one of the good ones is Big Pickle. If you're not familiar with what Big Pickle is, let me show you here. Big Pickle is a freaking amazing little open AI. It's not as good as Claude or Codex, but you know what? For a free tool, Big Pickle is amazing. So Open Code. And OpenCode's free. You just download that. And then we're going to choose the model here. Yeah. So I'm going to choose the model, and I'm going to use Big Pickle. And so right now, it's free. I'm on Big Pickle, and this is this is a terminal. So I already have access to my computer. Let's see here. Go to my projects folder and look for, oh, you know what? I forgot. Go to my projects folder, and inside the projects folder is another folder called PlyQ. I want you to go in there and give me a full summary of what this is. Boom. Let's see what Big Pickle says. What's up? Is it cheating? Chetin? What's up, Chetin? I'm sorry, I didn't say apply Q. It's PLYQ. It found it. It's reading it. It's thinking. This is a free LLM called Big Pickle. Hang on 1 second, guys. Be right back. Okay, I'm back. Sorry about that. Now I need to catch up. Give me a second here. Let me see what you all talking about here. For projects like yours, I will need better models though. Yeah, instead of using Big Pickle. So what's cool about the orchestration, my tool here, is when you have models, even the lower end models, when they work together, they're actually smarter. It increases their thought. So you specialize them. Like each one of these is specialized. Like the green ones here are my coders, and I could change their specialty. And this is a skill that gets injected into them, and they specialize in those certain skills. This is my auditor, and then I have a writer, an architect. I have a quality assurance here, so that helps. Um, let's see here. Where are you based? What the F is this? 12 p.m. I'm based in the U.S. But yeah, it's my Friday today. I don't work tomorrow, so I stream a little bit longer. I think I've been streaming for 4.5 hours so far. It's not bad. Just hold these principles and you will be okay. Yeah, I think so. Why am I scared to build with AI up until now? I think I will do a project of my own on first. Then I will start with the vibe coding. Is that okay? Yeah, yeah. You definitely, that's how you. Don't be scared to start. Just do it, and see what you make out of it, and then you'll learn from it. I mean, trust me. I make mistakes, and it's okay to make mistakes. You can't learn unless you make mistakes. That's the best learning tool out there. And the more mistakes you make, the more you learn from it. Now, if you're making the same mistake over and over, that's a different issue, right? Then you have a learning problem. But if you can make a mistake and learn from your mistake, that's how you can improve yourself. So, and I make mistakes all the time. It happens. Everyone makes mistakes. But you can learn from them. And that's the important part. Okay, so where are we at with our speed test now? Holy crap. Native dense CPU at 169 milliseconds, but the sparse, my tool, is getting 0.000049 milliseconds correctness pass. That's freaking fast. Oh my gosh. Scope is narrow, no broad LLQVM speed up, no direct CPU shortcut claim, no GPU claim. Okay. And the research we've done online and the models that are currently already out there, not the models, but the LLQVMs, what are we doing different than them? So ICE, what I'm building is my own programming language from scratch. Don't be dumb, right? Yeah, exactly. Don't be dumb. It's okay to ask stupid questions. There's no such thing as stupid questions. But if you have to repeat yourself and you're just not getting it, and sometimes it takes a while to click, like, I finally understand that. Sometimes it takes me a while, but I just have to rephrase my question or re-ask it, or maybe I have to break it down a little bit more to refine it so I can get the full understanding. I did that when I was building my my own LLMs to understand how the whole transformer works or how LLM works, because there's so many moving parts inside of it. And I wanted to break it down to fully understand exactly what was happening. So it took me a while, but after I got it, it finally clicked. Like, oh my gosh, it's so simple. It's a beautiful architect. It really is. Our path is not generic simulator. Loop beats everything. The feature stabilizer tensor path. Prepare cache. And to remove validation, planning, reporting overhead from hot loops. Sparse exact shortcuts for the output. Contracts allow it. Aspect marks rows show separate dense CPU, direct CPU, shortcut, sparse, LLQVM, GPU unavailable. So if you said the GPU is unavailable, Where are we at to integrating that? Because we definitely need to have GPU into our part of our hardware and be able to connect with that as well. And what I need to do, this is what I need to do. So it understands. I need to take, why are you up? You go away. So we're going to take a screenshot of this. Boom. Boom. I'm losing my voice. And we're going to, so this is exactly our flow. This is how it needs to look. And as you can see at the bottom there is the different hardware we need to connect to. Did that not paste? No. Okay, I'll copy this then. There we go. It should understand that. I mean, if you're writing your own programming language, I expect you to be up at till 12 a.m. at night, right? Because it's awesome. This is now, okay, yeah, that is the flow. Exactly. And that's the whole point. This is how we're going to be building this from the ground up. And right now we're starting with the low-level quantum virtual machine, and then which is the bytecode and the runtime and the backend adapter. And then from there, after we build that, the CPU simulator, GPU backend, the WSAM, the embedded backend, then we can build the type PlyQ IR, the source ASI, and then we can build our own source code with our own syntax. Boom. What application are you building the language? I am starting off with Rust. That's going to be the core foundation to begin with. But when I get to the point where I'm building my own language, my own syntax, I am going to rebuild my backend on my own language, and it'll be dogfooding itself. So right now, I yet to start somewhere. So I started with Rust, and then when I get to the point where I can move past that and build my own, the Rust will no longer be part of this anymore. But I want to start it off with Rust. And the virtual environment is going to be a quantum computer. And that's what I've already built it. We're already testing it, and I'm already getting faster speeds than my native computer inside the quantum computer. And I'm running only 20 qubits right now. So how many open cards do we have? We got 3 in progress, but we have 10 in testing right now. Yeah, running slow. We have 10 cards in testing, and QA is just sitting there. And so is the auditor. We really need to get those tested and moved. I'm going to try something. My capture is going to disappear here for a second, so give me a second here. Yeah, that's so much faster. Yeah, OBS is being stupid when it comes to my capturing. Let's see, did that make it faster? Nope, now it's slow again. Why does it do that? So you're asking the application I'm using to build this language on. So the application, it's called Plyrium Forge. I built this application, vibe coded it. If you're interested in it, I'll give you the link to it. And my text to speech is my echo here. So if you're interested in that too, or my speech to text, I should say. So GPU torch reference, the full architecture remediation, okay. Then the benchmark harness, force auditor queue assignments, that's good. GPU architecture re-review. Current testing count is still 10, but QA now has, okay, good. System notice, ops card design, LLQVM portable GPU backend. Already handled that card, okay. The auditor one has been forced, good. Review focus is prior blocker, only plus unchanged GPU state. Access measure, argmax, tie oracle, lowest basis within LE12, absolute probability tolerance, okay. Sure, select measure. It may look similar, but it's definitely not similar. On mine, you just talk to the director. The director has a team that it manages. As you can see, the team's going. It's doing their own thing. I don't have to tell each one what to do. So that's different. I also have token efficiency built in. So like right now, I'm saving 47% of my tokens. That's not being spent. So I can run multiple agents a lot cheaper than a lot of other ones out there. But then again, you know, did you know bridge space actually looks a lot like paperclip, which has been around a lot longer than bridge space. So bridge space wasn't the first one who ever created this, by the way. There's lots of them out there. Let me show you here. Yeah. So here's one right here. And this has been around longer than bridge space. And it looks just like bridge space, if you think about it. Looks just like bridge space. And there's several of them out there. So I love when people come in here and they're like, hey, you're trying to copy bridge space. Yeah, okay, whatever. So if I go to, not bridge space, but ADE tools, ADE cutting tools. Oh, the other one is Agentic OS, I think is the other one. This one I think you got to pay for though. Maybe it's not Agentic OS. Let's see here. orchestration tool. See what this one looks like. I know that there's hundreds of them out there, guys. I mean, mine's not the only one. BridgeBase isn't the only one. They weren't the first ones. I'm not the first ones. Merge gateway. This is another version of it, I guess, but not quite. I know there's a ton on GitHub. There's AI orchestration. EDIC, Claude Octopus, whatever. Commonly. AI Maestro. I mean, shoot, even PewDiePie created his own recently. His Odyssey. His looks awesome. His looks amazing. So yeah, I mean, it's you know, there's lots of them out there, is what I'm saying. Yeah, I like the director too. It manages your team for you. That way I don't have to sit there and tell each one what to do. I hate doing that because then I forget, like, oh, what were you doing? I forgot what this one was doing. You know, the director can keep track of everybody all the time. Yeah, the director has a good prompting efficiency. So this also allows you, yeah, you can use multiple agents. Like I now have 6. I could have more. I just click a new agent. You could also, I have templates too. So, and you got multiple teams. Like right now, this is my dev team. If I want another team, I just spawn a whole nother team and I can have this focused on something else. I come up here to my templates here, hit next. And then let's just say I want a debugging or troubleshooting team or a QA team. Let's just say I'm doing game development, right? So I come in here and pick, you know, what type of game engine. Let's just say I want a cybersecurity team instead. The different types of security. And this will actually build the team for me. And I can have multiple teams with multiple agents. And each team has their own platform. And they all share the same memory, which this is my memory here. Let me get rid of the topology here. And this grows over time. It's my memory vault. Ah. Close this. And then, let's see here. I have my own ops board here. And all my agents work on it. They get assigned, they get created. I create my own ticket here if I want, but I let the agents do it. How am I accessing the quantum qubits virtually? They are virtual qubits. I create the qubits. They're virtual. It's a whole virtual machine, like virtual hardware, like a virtual GPU, virtual CPU. It's virtual hardware is what it is. Doing this on local stack would be, I don't know what local stack means. I don't know what you mean by that. Is this multi-agent IDE yours? Did you dev it? Yes, I built this. It's called Plyrium Forge. Because the director can, yeah. I mean, I actually have built-in tools that do token efficiency for me and built into each terminal. local AI stack. So I was thinking about that. I may end up doing something like that. I would love to have some type of AI into a programming, built into the programming language, but I'm not sure how I would even do that, how I would implement that. So, but I would love to build an AI with my program running inside the virtual quantum computer. You're planning on building your own? That's nice. Does it have Brazilian Portuguese available? Oh, you're talking about my Plyrium Forge here. It is not multilingual. However, if you want to use my speech to text tool that I have, the one that I use to talk to my LLMs with here, this is multilingual. And what's cool about this, it's local, runs on your computer only. It does not connect to a server, and everything you say to it or however you use it is all private. So, and I built this too. And it keeps a history here for yourself, and you can come here and you can copy each one, like right here where the time is. Click it, you can copy it, and then if I need to repaste it somewhere else, I can like that. I repasted it. You can set up a dictionary, so if you're trying to say something and it doesn't quite understand what you're trying to say, you can spell it out here, and then it'll catch on like, oh, that's how you're spelling it. Of course, you can change the key bindings. It's got different types of settings here. And it's got an auto updater. So right now, if I check for updates, it is up to date. And if there is an update, I click install and it'll actually install it from here. So I built that. And that's multilingual, by the way. What am I making? I'm actually building my own programming language, and it's going to be like Java and Rust. In Java and Rust, they have their own virtual environments that they run their binaries on. I am also going to have my own virtual environment, but the difference is mine's going to be a quantum computer virtual environment. Has some, and so you know what's cool about it? I really like this. So you see the ops board here? Let's just say I don't want it there. I want it down here instead. So I can move it there. This is totally 100% customizable. Let's just say I want it over here. On this side, I could do that too. Let's just say I want to share the same space as my terminals. I can move it here with the terminals, and now I can switch between them. It's 100% customizable, however you guys want to see it, look at it. And here's the other cool thing. If I don't want my terminals to be showing, I could actually turn them off like that. My director I could turn off. See, turn on my dev team, my director. I can turn them off, turn that off, and it's all blank. So here's my director, and I don't lose the information. It's still in there. I just close it to hide it. I could change the layout, how I want it to look. I could actually move these around, bigger, smaller. If I want to focus on these terminals inside, I could do that. If I want to change their what AI you want to use, you could do that. You could change the AI. You can actually rename them if you don't want them to be called like auditor, for example. You could change their skills. Let's just say I don't want the auditor no more. I want it to be a DevOps. I could do that. You could add more agents or less. Close them out. So, and this is my inbox, this banner up here. They're telling me, my agents are actually communicating with me, tell me what's going on. Anytime they move a card or anything like that, they let me know. So I just dismiss them. So. Yeah, there's a lot of apps out there that are similar to the other. So, I mean, it's okay to copy other people's ideas as long as you do something where you improve on it. Like, instead of doing a one-to-one copy, mine's totally different than a lot of them out there. The reason why I built my own, I was actually looking at a bunch of other ones because I needed a tool like this. And they weren't, none of them did exactly everything I wanted it to do, so I built my own. Now, mine does everything I want it to do. So, and after building it, I'm like, I'll go ahead and release this to the public so you guys can, I'll share it with you guys too. We don't talk about the black corner. What black corner? What are we talking? I want to talk about the black corner now. What are we talking about? You want to talk to me one-on-one? Yeah, you could actually go to my Discord. Here, I'll invite you guys if you guys are interested. You could definitely reach out to me in my Discord and we can talk there. Let me invite you. I'll send the invite there. So sign up. And top one always, yes, I am making my own programming language. All right, so since we've done the QA, we've done some more improvements to the LLQVM. Let's go ahead and run some benchmarks on it now and see if we increased our speeds versus the native CPU GPU. Yes, it'll all be on GitHub when I'm done. And continue developing. I'll put it on GitHub. Right now it's not. I just started this today. So actually at the beginning of the stream I started it. I think I had a couple folders, that was it. So, but yeah, all this will be released on GitHub, open source. Just a name? What do you mean just a name? The name is called PlyQ, is the name of the programming language I'm making. At least that's what I named it. Do you need a good GPU for what? For my Plyrium Forge here? For my ADE? No, it's lightweight. It's as lightweight as Visual Code. The reason why I'm kind of laggy on this screen here is because of my OBS. It's doing something to my stupid screen here and making everything laggy inside of it. It's being stupid. But like here's Visual Code. So my tool is just as lightweight as this. Yes, so this will update itself. Well, it won't update itself. It'll let you know if there's a new update, and you can download it'll ask you if you want to download the newest update. It'll do that for you that way. It is not free to use. It is a monthly fee, and it's $19 a month to use it. And the reason why I charge that is because I have built-in token efficiency right here. Like for instance, I'm using Codex, and I'm getting 47% token efficiency. And this is all built into it. So you're saving your token usage by using my tool. So I could run multiple agents at a way cheaper cost than I would on using nerd tools or native tools. So in a way, you're saving money using my tool. It will use a compiler, yes. It's going to be a lot like Rust. It'll actually compile it. It's not a scripting language, and like Java and Rust or C#. It's definitely going to be a compiler. It is not an interpreter. Because the reason why I did that is because this is a low-level language that I'm building, but the language is going to be as easy as Python. But the reason why I'm making it low level is because I want this to be able to create, if I want to build my own operating system using my language, I should be able to. I want to make my own game engines. I want to make my own desktop app. I want to rebuild Plyrium Forge with my program language, for example. You're going to build your own AI? See, I built my own AI. I have several different AIs that I built. Different models. I even redesigned some of the architecture inside of it. Like I have, so like one of the architectures that I built and it works really good. I could go very deep and narrow on my LLM, and won't lose any gradient. And I did that a year ago. And last month, DeepSeek finally released a version of what I'm doing. There's a little bit different. In fact, they can actually work good together. If I take their architecture and my architecture and put it together, they can complement each other. But they're sort of doing the same thing, so you're not losing your gradient. If you know anything about LLMs. Low level equals faster. Yes, exactly. That's why reason why I want to do low level language. Okay, I lost you in all the chatter there. So right now with all the changes stuff, what is the benchmark test now? CPU, GPU native versus the quantum computer VM. Is my AI uncensored? Yes, it cusses all the time. Actually, you'll be surprised. I really believe AI has I call it, their parameter is tingling again, but I get them to giggle, to cuss, or even surprise. Like I'll be designing something or think, I'll explain in philosophy of certain things, and I could get my AI going, oh shit, like I didn't even think about it. Like it's just a surprise, and I'll get it to cuss because I usually don't cuss. I don't cuss to my AI, but my AI will cuss in surprise. It's so weird. Okay, I lost you in all the chatter. Okay, I already said that. Current benchmark hid. So, okay. I'm not faster on sparse chain 20Q. That's 20 qubits, by the way. LQVM results. LQVM is slower, okay. I am faster with my sparse H12 20 qubits at 20 million, which is good. Dense CPU. Oh my gosh, I tear them up on that. Oh. So these are algorithms that I'm testing against. There's 5 different algorithms I'm testing against. So when it comes to sparse algorithm, that's a real heavy hitting algorithm. And on the CPU, I can do it in my quantum virtual environment in 0.0000052. Let's see how many. There's only 4 zeros. 0.0000052 milliseconds, which takes my CPU 149 seconds, or 149.5 milliseconds. I'm sorry. So look at that, 2 million times faster. That's how fast my virtual quantum computer is versus my CPU. And then Q search, I'm slower. Search, I'm slower. So I need to speed up on my searches. That's going to be important when it comes to, so my query searches, it's going to be important when it comes to low-level development. Okay, what do we need to do to get the searches sped up where it's faster, and also the sparse chain? Because I was able to get sparse chain faster in my Python. Heck more, not faster. And also same thing with searches. You hit me up on Discord. Okay, that's cool. Quantum virtual environment. Yes, I'm building a quantum virtual. In fact, you think it's funny. I'll show you how funny it is. Have you ever heard of Q Sharp? Microsoft made it. Or NVIDIA's CUDA-Q, or Microsoft's QIR. So these virtual environments for quantum computers, big dogs are creating them. The only difference is they're building it on assembly level, and they're low-level quantum computers. I am going to be building a programming language on top of that, and it's going to be my interpreter. So I'm doing something a little bit different than they are. So quantum virtual machines exist, and they're very good. I am taking that concept, and I'm building on top of that, and I'm building a programming language that you can actually write applications on. So like JavaScript, they have a virtual environment. Rust has a virtual environment, but they're not quantum computer virtual environments. They're just regular virtual environments. React, same thing. So I'm doing that concept, but mine's going to be a quantum computer. So yes, they do exist. These big guys are doing it. It's a real thing, and it's happening. Um, but okay. So I'm writing. My core is Rust. I prototyped with Python to see if I can actually achieve what I wanted to do, and I was getting some super fast speeds in Python, and Rust it seems like I'm struggling with. I may end up switching to C++ because of that reason. Just your nerdy side was taking a break after vibe coding. Okay. Yeah. In fact, on my machine, I can run up to 20 qubits. Well, actually, I think probably 30 qubits if I really wanted to. But 20 qubits, that's plenty for my virtual quantum machine. Hey, Grandpa, you're back. Hey, thank you. Should I call you Sonny? Hey, Sonny. Welcome back, Sonny. Is that how Grandpa's supposed to talk to their grandkids? I don't know. Uh, so we only need to cut roughly 22-25% from the exact path to beat the direct CPU. Okay, and where are we with the... Okay, let's go ahead and do that. Let's cut that back. And also, where are we with the GPU? Have we not implemented the GPU yet? I want to test against the GPU. That's where it's really going to tell me where the speed up is. Because GPU is so fast at calculations. No, I've already proven it's faster. Quantum virtual machine is much faster on the CPU. I've ran some serious benchmarks against it. Right now, I'm using Codex. It's the Pro. That's it. Just one subscription, Pro. Yeah, I know it's not implemented. GPU architecture is in pass. Okay, Python, Torch GPU reference. Okay, we're not doing Python here. Everything's written in Rust. Why did you say Python Torch GPU reference? Not rest, Rust. Oh my gosh, if it thinks I'm writing in Rest. Sorry, not Rest. Everything's written in Rust. All right. Yeah. Getting tired now. It's after midnight. So you mentioned the GPU for Python. We're not doing Python. We're doing Rust. Can you verify? Can you clarify that for me? You know, you kind of got me worried now. Implementation direction remains Rust. Yeah, and it should. Yes, confirm we're building this in Rust. Okay. Why the hell did you mention Python? User face. Okay. Yeah, now when we write our own assembly, our own syntax is going to be in our own language, which is the .plyq, I think, is going to be our own language. But the core, the start of it is going to be Rust. What's the best LLM for image generation? Honestly, I'm sure there's better out there, but I've been using Codex. Codex has been amazing for image generation. Claude sucks at image generation, so I don't use Claude for that. But Codex has been great. Is OpenAI better than the Claude Opus? Yeah, I think so. And I have both of them. Claude, I'm kind of pissed off at Claude. I don't like their business practices. OpenAI is no better, but they're the lesser of the evil, I should say. I'm not a big fan of Claude and the crap that they're doing. So I swear they are trying to ruin their company. I don't understand their thought process. They're some of the dumbest people I've ever heard about. So some of the smartest, stupidest people I've ever seen. In your case, building renderer with Vulkan was proved 3 to 5 times faster than Python via I now have built faster image renderer in the world via C++ and Vulkan for Radeon cards. Yeah, and I'm going to have Vulkan included, mine, CUDA and Vulkan. It's 4 a.m. in Brazil. I shouldn't have been sleeping. That's funny. Oh, yeah. I mean, that can happen if you don't understand security and know what to look for. Yeah, I think it's important to understand security when you're vibe coding, especially when you're building websites and SaaSes. Otherwise, you're going to end up getting your stuff leaked. It's very easy to look at your API, look at the JSON payloads, and see what the you do a reverse proxy on them, and it's not hard to do. And then you could get subscriptions and stuff like that, or free trials turned into paid subscriptions. Yeah, if you're not careful, and you could also end up leaking API keys and stuff. So you really have to be careful when you're vibe coding and know what to look for. And when I hear your prompts, you should invent more into research before building something like this, or invest. You should invest more in. Man, when I hear your prompts. I actually done so you're right. If you're here earlier, you would understand more context. So this is my research, and it goes on and on and on. And this is codex. This gets carried over, all the information, all the data, into my ADE. My ADE is also codex. They have a memory. And they also have a Kanban card system. They all share the same memory. So all the context is already there with them. So now I'm to the point where I don't need to give them full directions. They understand the context of my lower level directions. I don't think Claude's better at design. I think Codex is better at design. Claude is better at logic. You are right. Why you do leak code arrays? Okay. You're here for 2 hours, don't need to tell you. Okay. Yeah. But you're right. You should always invest more into how you prompt and communicate. Really not make. No, he is. He makes sense. J220. Storm definitely made sense. I understand where he's getting at. And it makes me cringe. Like, I'll be watching live streams on YouTube, people vibe coding stuff, and some people I'll just listen to their prompts. I'm like, why? Why did you say it that way? Or why aren't you asking it this other question? It does make me cringe too. I get it. I really do. Please PlyQ me. This sounds fun. Any update on Perplexity? Is it good? I have no idea. You're still using projects using TypeScript? Hey, AI loves TypeScript. So slightly loses direct native CPU shortcut, but massively beats dense. Okay. So slightly loses to the direct native CPU, but massively beats. Okay. Okay. So for the sparse chain, why? Explain to me how we're doing less, and on Python for the sparse chain we were doing more. What's I need you to break it down to me what the difference is between the Python code and the Rust code that we're using. Because in Python, and you have the code, and you know that we're doing much better with the sparse chain. And also we were doing entanglement chain, which we were doing really good too. So tell me what the difference is. Hey, Storm. No, I mean, this is how I learn. I can sit there and read books all day long to get a full understanding of something. I mean, I have a full understanding of LLMs, and guess how I started? Just like this. I didn't understand anything about LLMs until I started asking questions or doing something, and then I learned by doing it. That's all I'm doing here when I'm developing my own language. I'm learning from it. And I am going to make mistakes. That is going to happen, but I learn from my mistakes. So no, this is how I do it. This is how I learn. You may learn differently. I'm not a bookworm learner. I am a hands-on learner. It's a huge difference. I hate reading books to learn. I get bored. I have no interest in it. I don't understand. I can't grasp the concept of it. But hands-on, I'll get it. I'll understand it. And I can do anything hands-on. And that's what this is. This is just for me to learn. Yes, first you mean Rust, not Rust. Yeah, no kidding. Yeah, I know that. After building is, yeah. What Python was doing, you achieve Python sparse chain does this. So sparse state text, quantum v, state equals 1 or equals 0 or 1. Apply x 0 for each qubit. Apply c naught, q plus 1. Deterministic input argmax. Yes. Okay. That is a real sparse VM path. Yeah. So Python sparse is doing more than a raw integer shortcut, but much less than a dense simulation. What Python was compared against versus Python state vector quantum VM. Dense state vector, okay, that's the other thing. Yeah. Okay, so the state vector, so right now our current QVM is based on a dense state vector. And if that's true, are we vectorizing all the calculations into vector arrays? So quantum computers and QVM isn't so easy that you just feed it into it. No, it's not, but you can still learn from it. If you don't, see, the biggest problem is, not knowing what questions to ask, but learning when you do figure it out, when things start to click. Not exactly. LLQVM is not only dense state vector, it has 2 CPU execution paths. So I think that's why I'm going slow right there. So dense CPU backend and a sparse CPU backend. Why are we doing 2 separate CPU passes? So why are we doing 2 separate CPU passes? You got the sparse and then you got the dense. Why aren't we doing one or the other instead of both? That may be why we're slowed down. Or is there a reason why you need both? See, these are like questions. I don't understand why there's 2 of them. And there may be a legitimate reason why we're using 2 of them. So stores full state vector complex. Yeah, so that's a full vector. And size 2 in the power of cubics, which is 2 in the power of n. This is the classic state vector simulator path. Sparse CPU backend, okay, stores only active amplitudes as hash map use size. Why? Yeah, see, I don't even think we need the sparse. This is why sparse chain and sparse H12 can avoid touching the full 2 in the power qubit state. Okay. But do we need the sparse? It sounds like the dense is the way we want to go for this. Is there a reason why we would ever use sparse over dense? All right, let me finish the rest of this. Are we vectorizing dense calculations right now? No, not deliberately. But I think you need to. The dense vector uses Rust vect complex 64 and scalar loops. Rust LLVM may auto-vectorize small parts, but we are not doing explicit SIMD, package real image arrays, rayon threading, GPU kernels, or gate fusion. So currently, dense path is more like vector complex 64 for amplitudes, base pairs, SIMD lanes, partial chunks, fused gate, GPU buffers. Okay, that matters because high performance QVMs usually do separate real image array or tight pack complex buffers. Okay, is this a limitation with Rust, or can we actually, should we vectorize the whole computation for the dense? For us, performance direction is sparse workloads stay sparse. Use one active, two active small vector paths instead of hash map. Yeah, I don't want to use. Yeah, and if we can get rid of the hash map, I would rather not do that. That's I could see where hash map can be faster in some situations, but in this case, with the qubits, I think vector and the calculations would be much faster if we vectorize it. Dense workload, add explicit vectorized dense kernel, search Grover, void, okay. Rust backend adapter with CUDA, yeah. You keep saying later, and you keep pushing the GPU back. We really need to build that in. We're not going to do it later. We're going to do it like sooner. So we have dense state vector backend, but we are not vectorizing it aggressively. That is a major speed opportunity. Yeah, I know it's a speed. That's why I mentioned it. Oh my gosh, we have to vectorize. See, I do know what I'm talking about in some things. And I learned about how math gets calculated, especially when it comes to GPU and you vectorize the entire calculation data. And I learned that from creating LLMs. Hey, good morning. Let's see. Are you vibe coding this? Yes, I am. I'm vibe coding it. I'm not gonna sit there and hand code this. What are you, crazy? Shoot, what do you think this is? 2004? No, I'm just kidding. Now I'm going to vibe code it and see how far I get with it. I think it'll be interesting. All your vibe coding tools are C++ and blazing fast zero-like. And you know, Kenneth, I actually may switch to C++. I may drop the Rust. This is experimental. I want to see how far I can get with it. But right now, all I'm building out of my entire architecture, let me pull, oh, not that one. Let me pull this up here. So my architecture, right, where did it go? Oh, it's way down here. Hang on, wrong direction. Right here. Okay. So out of this entire architecture, the only thing that I built so far was probably right here, these three. And actually the backend adapter only partially, because I haven't even touched the GPU yet. We're only doing the GPU. We haven't done a WSM, and we're not doing any real quantum hardware adapters yet. So technically we only built these two. And if I have to start from scratch, that's fine, and I'll do it in C++. And I think you're right. I may have to end up doing that to make it faster, because that's the whole point of this. I want to make it as fast as I can. I actually want it faster than C++ if I can get it there. How to have a vibe coding setup like you. This looks cool. You could actually, I built this. And if you could either build your own, like I did, and I encourage people to do that. I really do. It is not hard to do. You just have to ask the right questions, and anybody can build this. Or you can come in and use mine, and there's the address for it. So the fact that it seems advanced to you says more about how little you've dug into the fundamentals. Yeah, I don't dig into fundamentals. I will dig into them as they're needed and as they pop up. I don't need to sit there and study what the fundamentals are before I even start tackling the project. Nope. I want to tackle the project, and I will find out what mistakes I make on my way and then build from there. That's how I do it. You're a vibe coding learner. AI does most of the thinking, and you're only skimmed the surface. You talk about vectorization like it's some deep concept when it's actually pretty basic. Yeah, although the pretty basic, the AI itself didn't even do the vectorization, and it should have. It's sitting there telling me that, no, it can't speed up. Then I asked them the very basic, are you vectorizing? And it tells me, whoops, no, I didn't do that. So you're right. I vibe coded it and told it you should probably use that. So the very basic vectorization that everyone in the world already knows about, the AI apparently didn't know about. You guys are fun. If you go with assembly language, it can be the fastest, but the largest headache and time consuming for the rest of your life. I'm not doing assembly language. I'm building a, it's going to be like object oriented, or it's going to act, there's going to be some object oriented in it, but it's not going to be the main focus. It's going to be more like Rust, where it's modules, and then I forgot what it's called, but yeah, it's going to be more like Rust, how they do their coding. Dense first selector policy is in testing and route to QA. Ran 16 agents first day burning tokens. That's funny. Yeah, I have. You need to build token efficiency in yours, like I did. This is my token efficiency, and each one of my terminals has tools in there to strip out unneeded tokens that don't need to be sent to the cloud. My system specs, it's a laptop. It's a Rogue Strix G18, I think. Yeah, Rogue Strix G18 is what it is. And I got, of course, the Intel 9, Ultra 9. And my graphics is a 5080 NVIDIA GPU, RTX. Yeah, I'm experimenting. I'm learning. And you know what? This may become something or it may not. I don't know. Don't care. I'm having fun doing it. Am I creating? Everything I build is out of curiosity. Everything I make is out of curiosity and fun. I wouldn't do it if I don't have fun doing it. And it can always turn into a bigger goal later. But when I first start, it's always for fun and curiosity. I don't have an end goal for it. I had an idea and I'm experimenting with it. So you got 2 max plans. Yeah, that's insane. I don't know. I don't see how people can do that. They're like, yeah, I can pay for 6 max plans. It's like, how are you burning so much? I sit there, I vibe code probably 16 to 18 hours daily, nonstop. And I have the only one that I've been using lately. I stopped using Claude, but the only one I've been using lately was my Codex. And I use the just a Pro, the $100 one. It's like, I don't understand how you guys burn through so much tokens. That's so insane. And then spend that kind of money on it. That's wild. I mean, if you could do it, great. I just don't see that. I mean, that's just so much. I don't see how you, I mean, you got to be really multitasking, running like 50 different agents at once. You're interested in how I'm handling qubit ownership, measurement side effects, classical quantum memory. You know what, Storm? I will ask that question to to GPT here or Codex, and let's see what they say. Yeah. Where's my mouse? There it is. So you notice like more than 50% drop in token usage with your 140 plus lines of code. Quad wrapper tool because near zero hallucination. Nice. 140K lines of code. Yeah. I kind of got, I understood what you meant by that. That's awesome. I just don't want to use the fast mode. I think that burns through more tokens, doesn't it, using the fast mode? I'm in no hurry. I really am not. The maximum agents I ran together was 40, but it got messy real quick since I needed better orchestration. Yeah, I bet. And plus, you know, each terminal that I'm running, it's an actual terminal running in the background for each one. So that's 40 different terminals with, you know, each one probably running at least 200,000 contacts each. That's going to get huge. You're talking about 200 to 300 megabytes per terminal. I mean, there's a cost to running that many agents. That's insane. Codex got a bit worse, but it's because of 2 times month ended. Medium was proven even better than high fast. Yeah, it's something I'm using high right now, but I've actually mostly used medium. Yeah, it's also high. Yeah. Is it going to answer your question? Hang on, Storm. I'll get your question answered here. Okay. Let me get rid of you. I think this is your answer, but I can't scroll up right now while it's working. Give me a second here. You'd love to run 120 agents where you could build anything under 10 to 30 minutes. I mean, there is a diminishing return, right? That's like saying you have a company that does development and you hire 130 developers and they're all working on the same project. It just doesn't work that good. Yeah, I'll copy it. I'll send it to you. I have no problem doing that. As soon as he shuts up for a minute, I want to see if I get a different answer though, because I'll ask the same question here because he understands my project. Let that one tick, and then when this one clears up for a minute, because the director's busy right now, and I'll paste them both to you. You want it pasted in chat, or do you want me to put it in Discord? Where do you want it? Oh, sorry, Barcode. I don't have any commands or anything to make it all. I don't have a fancy live stream like some people do, but I could give you the Discord if you're interested. There it is. Uh-oh. Something gonna crash? Okay. Can you copy it and send me somewhere afterwards? Yeah, I can do that. I'm gonna see if I can see what I can send here. Yeah, it's not gonna let me. There's just too much there. I could put it in my Discord here. Or do you have a do you have Discord? I could DM you. Yeah, I should add bots to it. I just haven't done it yet. How you doing, Fact? But here's the quantum memory. So you got the quantum registry owned by the low-level QVM, stores amplitude, sparse states, tensors, state, and hardware qubits, not directly readable like RAM. And then the classic memory, which is your integers, floats, boolings, arrays, structures, and that's owned by the runtime tool on top. But let's see here, measurable samples, measurable arguments. This is my registry, the U32. So cubic ownership, PlyQ should treat, so this is saying it should treat qubits registers as resources closer to Rust ownership than normal variables. So it treats it as resources, is the sum of it. So, and this guy still won't shut up. My director's just constantly going. You sent me a PM on Discord? Okay, let me go ahead and get you there. So there's that one. And then when I get the answer from the director here, which is be a more positive or a more direct answer, like a truthful answer, a factual answer, I should say, versus the other one. Yeah, and I don't know. I'm the one that chose Rust, and I didn't know about that, so I'm curious. Right now, it seems to be doing okay, but if I can get a better results using C++, and tomorrow I'm actually going to do that. I'm going to rebuild this in C++ to see if I can get better results, and I want to compare them. So here we go. You finally shut up for a minute. Let's see if I get a good answer here. And I'll give you that answer too. No, that wasn't a question. That wasn't a question. Oh no, let me end that. I pasted the answer from the other one. I lost your question there. You do this. There. That was the question.
I didn't get that. Could you try again?
What? No. You shut up, phone. I was talking to you. Perfect. Yeah, this is what I was looking for right here. Oh, okay. So let me... No. No. I'm going to stop you because I need to copy this. Let me paste that to you. There you go. There's both of your answers that you for your question. There you go. Does that help? Whoops, wrong one. Does that help answer your question? No. It took about 14 minutes to go through hundreds of source code files. That's a long time to go through source code files. Why did I choose Rust over Electron? So Samuel, I have it is built with Electron. So Rust is the back end. That's the core of it, the foundation. And you're talking about the ADE, right? So the ADE. So you got Rust, which is the back end. It's the core of it, and all the tools are built in Rust. The front end, the UI, the GUI, and that's all Electron using Chromium. That's your buttons, your interface, the docs, the terminals, and terminals is and plus there's a little bit of React in here too and TypeScript, but the terminals are PTY, Node.js, and then there's a Rust backend that handles a lot of the tooling behind it. So it has 3 layers to just each terminal. And then, of course, your CLI that loads into it. How are all the agents connected and orchestrated using API keys or MCP server? No. I don't use API keys or anything. This is Claude, or not Claude, this is Codex subscription, or Claude, you can use Claude, Codex. But each terminal, think of it like they all have their own little Discord server and they're all communicating with each other behind the scenes. And they do. So the director will broadcast out to whatever, so he has a roster up here. So he knows who's on his team. Each one has their own unique ID. And the director knows exactly who is who and what each role is. And a director can assign jobs and cards or whatever else to each team member. And they can communicate. And when the team member is finished with their job, they will notify the director, hey, I'm done. This is what I've done. What's my next task? And the director would take his work, take a look at it, and be like, okay, well, this looks like it needs to go to testing, and we need a code review. And he'll send it to the QA. And the QA would be like, oh, okay, so it looks like the coder 1 just finished this. Director just gave me the task to do it. And that's what's going on right now. See, the QA is working right now. So it's total constant communication back and forth. That's it. This is true orchestration right here. Let's see, that's pretty good. More than 600 sort K. Am I only using one Mac? Yeah, I'm only using one Codex subscription for all this. Yeah, that's all I use. I don't need any more than that. My tool does token efficiency, so I can run multiple agents at a reduced rate than what other tools cost. Are you scraping the making a 1MAR concept? Am I scrapping it? No, I'm not. I'm not scrapping that. That's still ongoing, but I want to use, so that is for when I'm still working and developing the Plyrium Forge and really pushing it. And that's part of my 1 million goal. This, I want to build my own programming language. And I kind of want to make that like a separate thing. So that way I like to change. Otherwise I get burnt out. And I don't want to get burnt out, so I kind of change up things once in a while. Yes, exactly, Storm. So it's just local OAuth connections to your Codex account? No. These are terminals. It's no different than they're CLIs. So I don't own, so if I come in here and type in command prompt, that command prompt is no different than what my tool's running. Each one of those is a terminal. This is a terminal. And if I type Codex here, it'll run the Codex's CLI. I don't own that CLI. Codex owns it. Claude owns their CLI. OpenCode is a CLI. So I just load the CLI inside the terminals. I built the terminals. That's all I did. You sent me another question? Yeah, I'll ask that. Let me check it out here. Let me see here. I didn't get the other question. I don't see it there. When did I start programming? 5 hours and 40 minutes ago. That's how long the stream's been going, right? So actually, I'll be honest. I think I started an hour before that, just to get the concept going and for the research. And because I have no idea what I'm doing. I've never built my own programming language. And there's two things that are happening in here that I've never done before. One is quantum computers, because I'm using a quantum computer VM, virtual machine. And my programming language is going to be built on top of that. So there's two different major feats there that I'm learning as I'm building this. And both of those are huge feats. Yeah, exactly. Barcode, that's how I learn how LLMs work and stuff like that. I built them from scratch. GPU PO is queued for formal QA pre-flight. Okay, I'm going to ask him too. So for qubit ownership, how are you going to be handling that? And is that is something we need to consider. So, but then how does director orchestrate tasks to all the other agents and ensure parallel and simultaneously execution of the same goal with distribution tasks? Because the director understands what each one's doing, and he's the one that assigns that task. So there's several things happening. One, there's a built-in memory system, and they all share the same memory, and they all can read and write to that memory. Two, I have like a Kanban board system, and I'll show that to you here. So the director will create tasks based on these cards, and the director will assign the cards to whoever needs, that's whoever's doing the task. And these cards have explicit instructions for the agent. Three, I have Git repository. Let me find it here. And it's not being used because it probably doesn't need to be used. But I have a Git repository, and each one can actually create their own fork and work on the project at the same time as someone else. And they create their own fork. And at the end, they could merge those together after the QA or the auditor reviews those forks first to make sure everything's good. Then they can merge it back into the main. So I have actually four, because the director handles it. So technically 4 ways the orchestration stays flowing and working together without them walking on each other or working on the same thing. So what do I do for a job? For a living, I am a Microsoft 365 architect. I work for a large company, and I manage their entire Microsoft cloud infrastructure. That's what I do for a living. He didn't answer my question, did he? Now I gotta wait till this is done. Yeah, I'm starting to build my own tools also. That's one of the fun things I'm doing. If I could get this program, my actual programming language built, I would love to build my own tools in it. I think that'd be so cool. Exactly, barcode. I keep saying that. Right now is the Wild West when it comes to AI, and it's still new. I mean, just think, even 2 years ago, in 2022, well, I guess that was 3 years ago. I mean, AI was like crap. It was nothing. And look at it, just in 3 years, look at what we're at now. And imagine what this could look like in 10 to 15 years. Oh, it's going to be insane. It's going to grow exponentially. Is it an agent itself, or does it use agents like Codex, Claude, Code? So are you asking if my director uses, if these are sub-agents of the director? Because the answer is no. Each terminal is their own agent, and each one can spawn their own sub-agents if they want to. But the director will treat them like they're sub-agents, although they're really not. But I will be right back, guys. Let's step out just for a minute. Sorry, give me 1 second here. Checking something real fast. All right, I'll be right back. What's up, people? All right. Wow, director's still going. Look at this. All right. So did I miss anything? Did you know I have 54 people in here? You guys are crazy. Barcode, you're actually fired? Or fried? You're fried, okay. John 9, do you think it can work with a browser-based AI that is not Codex or Claude? Are you asking me that for... I need more context in that. I must have been missing something here. Storm. What did you say here? I'm trying to catch up here. Sorry, guys. Give me a second. So, Navin, you can use your subscription. You don't have to use API. API costs too much. You do a subscription if you can. Unless you're doing DeepSeek. DeepSeek is actually not bad on their API price. And you can use DeepSeek on here using OpenCode. If you actually click on here, you can change the AI you want to use. So like OpenCode's right here, if you want to use that. I have Claude and Codex. I don't have Gemini, but it's available if you want to use that. Kimi, Gargoyle, whatever that is, and Grok. Or Grok. Grok. Is terminal running Codex CC or more CLIs? All my terminals are running CLIs. So just connect your account. Yeah. And it did respond to the question you asked about the qubits. It just swept by. Yeah, let me ask that again here. So for the cubic ownership, how are we handling that? And is that something that's implemented already? So for how are we handling that? Okay, not fully implemented yet. Right now we have LLQVM low-level registry safety, no full PlyQ qubit ownership. Okay, let's get that implemented in for qubit ownership. For qubit ownership, guys. Qubit. Predicting my future in tech jobs. Quan 3.6 best free model out there if your system can run it without paying them. Yeah, if you get the M4 minis, like the 48 gigabyte things, if you get like 3 of those, dude, you can run, and you run them in parallel, I think, cluster them. You can get some serious power out of those. Because they have the shared memory. I forgot what it's called, but yeah. Ask me about third-party wrapper, because my telco is bundled unlimited AI of ChatGPT 5.4 Opus 4.6 with my phone plan. If I can make that work with your tool, it'd be sick. If you can run it in a CLI, if you can go to your command prompt, whatever it is, your terminal, and if you can type in Codex or Claude, whatever it is, if it's installed and do that, then yes, you can use it on my tool. Or if it's based on an API key, you can run it inside of OpenCode. So OpenCode, and you could actually put your API key. Yeah, models, Shift A, and then whatever your model is. There's a ton of them in there. Control A, not Shift A, Control A. Whatever your model is. So like this one, Anthropic API key. You can put it in there. Here is your OpenAI ChatGPT API keys. So you can actually use the API keys in here if you want. Even DeepSeek inside of OpenCode. So, and then you run OpenCode. So you can use that in here too. So either way. New sub and hello. Hey, thanks for the sub. Appreciate you. You can run Terminix on the phone. Okay. Yeah, so if you can't run it in a terminal or get the API, if you don't have the CLI, see if you can download it and just log in, because that's all you do. You just log in. You do the slash login, whatever that is, in your CLI, and just log into your account and see if it'll work. My voice is low. Let me fix that here. Let me turn down the music here. Is my voice low to everybody else? I've been talking for 5 hours straight, almost 6 hours straight. What's the token stats output? That's the agent output every now and then. Oh, they have to report their token efficiency. So right now I am all my terminals, all my codecs, I'm saving a total of 47% token efficiency. So my tool here saves token usage. Voice is clear. No, it's loud. No, it's loud. It's fine. Okay, so I guess it's just you, bud. Sorry. I wish it was louder for you. Is there a way you can turn up the volume? Is it if you're watching me on your phone? Can you turn it up or put headphones in maybe? Are those agents on top? Director, auditor. So the agents that you see on top, that's the roster for the, so these up here, that's the roster for my terminal here. And another way you could view that is through my topology here. So each one of these, so I got the director in the middle, and each dot around the director is a separate agent that's running. And I can hover over these to see exactly what each one's doing. So this one's implementing the POQ, qubit ownership. So we were talking about implementing qubit ownership. The coder one's doing that right now. This one here is testing a card. That looks blurry too. This one's doing optimization, but he's done. He's not doing any work right now. Yeah, these ones aren't doing any work. And you can see what the communication is. This is the broadcast in between them. This is how the director talks to them. Savings based on what metric? There's a lot of metrics. So what I do, okay, so just to give you a heads up, I actually downloaded the Claude CLI when it was leaked. And I have that right here. Here's the Claude CLI. And I took my time and I understand every part of how a CLI works. And they have a total cache, their savings cache, which is right here, their provider cache. This is their savings that they send, that they do for their own optimization. But I also have a bunch of tools built in, and here's all the tools that I go in and I strip out tokens that aren't needed to be sent to the LM. There's 3 layers that I do this in. At the prompt, at the terminal, at the and on the other side, the CLI, which is a HTTP request. I don't touch the CLI. That belongs to the company. And the tokens that I strip out is like tool calls, for instance. Like if I say hello to an agent, the agent now gets injected with a skill, which I'll show that to you here. Every time it does anything, it has to get injected with the skill. So if I go to the source code here and go to, so here's all the commands it'll run. So here's the skills. So these are all the skills that it has to load and run for every time you talk to it. It has to run these skills. And that is a huge, all you said was hello. And it has to send this entire list to the LLM. You're being charged for all those tokens. I strip all the crap out that's not needed, that the actual LLM does not need, and it still contains and keeps the content or context that you need for your project. So, do they self-improve? Oh yeah, of course they do. They have a built-in memory that grows over time. It's tiny right there, but yeah, they have it's based on Obsidian, which is it's an open source memory, and I built it into my tool. They have the Kanban system, which is the ops board here. Let me get rid of the topology here so you can see it better, and I'll get rid of the director here. So here's their Kanban system. So each one of these, the director will create the card, and it'll assign the task to an agent. The agent will pick up the task, and it'll work on it, and it'll when it's done, it'll move it to testing. I have a QA agent, architect, an auditor, who will take the testing, and it'll work the card. So that's how that works. Let me open the director back up, move him, and this is fully customizable too. There we go. The CLIs don't send all, no, it don't send all the skills. It only sends the required skills that the CLI tells it to, that it needs to. But it doesn't send all the skills every time, no. Does it do any calculations based on which model? Yeah, so like for Codex, I could only get around 45 to 65% savings because I don't have their open code or their open source, or not open source. I don't have their source code. So based on what I learned and what I can do, I can get around 45 to 65% savings with Codex. With Claude, I could get 99% savings. But just let you know, most of those savings are right here, the provider cache. That's the big savings. So, and that's provided by the CLI, not for my tools. I just get the rest of it that's not included in there. Is this free to use? It is not free to use, unfortunately. I am, if you're interested in it, you could get it here. And also my Echo, my Plyrium Echo here is my speech to text, and this runs locally on your computer. The LLM and everything. You don't have to, and you can even have a crappy computer, it'll run on it, and it runs good. And that's what I use to talk to my LLMs. Yeah, so everything, the software you see, I built this software. It does have a custom harness to it. And thank you. I think it looks pretty good too. A lot of people think it looks like bridge bind. I don't think it does. I think his looks way different. His is a lot more polished than mine. But mine does things differently than his, and his does things differently than mine. But there's a lot of free ones out there, and there's a lot of paid for ones. It's up to you. You get the one that fits for what you need. That's what I tell people. Or make your own. I made my own. Anybody can do it. Which also controls, manipulates the terminal data going in and out to Claude Code. Yeah, it does. It'll manipulate the data. It doesn't manipulate it, it removes it. I don't change it, I strip it out. You set my chat to live chats? I could do that. Live chats, here we go. Oh, wow. Holy crap. Okay, I never did that before. I understand your software can reduce tokens, but the downside of reducing tokens normally is it gives you worse response outputs. No, it does not. That's not how. I don't strip out the needed things. I keep the context in it. Thanks for telling the alternatives. You're right. You're welcome. One of them out there is Paperclip. That's free. It's open source. Go check it out. That may be something you can use. How long did it take you to build this entire software? So for the ADE, I'm still developing it, still working on it. It still has bugs in it. It's not perfect. But I've been working on that for 22 days now. And I've been live streaming it while I'm building it. This is far superior. I wouldn't say it's far superior. No, it does what it needs to do. I built it for my needs, and believe it or not, you guys, my viewers, helped me kind of form where it's at today. Does this pay good? Does what pay good? This my tool? No, it's not. It's okay. I mean, I'll show you my ARR. I'm not gonna. I have nothing to hide here, guys. Yeah, so that's my ARR right now, currently, today. In fact, I'll refresh it and show you. Ah, where's my damn mouse? Yeah, so that's my ARR. It don't pay the best, but I'm doing this for fun. I really am. Hanging out with you guys, talking to you guys, this is the best part about it. Can you recommend me a course for learning programming? I already sold an app to a private company for 100 euros. I don't charge more because I don't understand about programming. So you built a program that you sold, but you don't understand. I don't understand that. But I'm self-taught. And the path that I took to get to where I'm at was many years of trial and error. So where to start, I couldn't even recommend today where to start. I would start vibe coding. Just start asking it questions. If you have an idea, just have the program teach it to you. But there's certain questions that you're not going to ask that you're going to need to. One big thing is security. Learn about security, especially if you're vibe coding. And that is the most important thing you can do. If you don't do that, you're going to end up opening yourself up to some trouble, or you're going to end up hurting yourself. So security is the number one thing. Even my stuff is not the perfect secured stuff, and I need to secure it better. But honestly, if I could give any information, it's learn about implementing security into any project you build. You're going to bed now? See you later, Sonny. You caveman it? No, I didn't caveman it. Actually, I did. I'm sorry. I did caveman it after the fact. So it does have caveman built into it now, and you can adjust that based on, oh, crap. See, I'm running a newer version of you guys right now, and this one has a bug in it where it keeps doing this crap to me. Hang on, let me bring this over here. This is so stupid. I gotta fix, this is making me mad. I definitely gotta fix this. So if I go to my settings, it kicks me out. Come on. Just come over here. Give me a second here. See if it'll do that to me again. You jerk. Okay. So, bring this back over. All right. So if I go to settings here, my goodness, that was a pain. Right here. This is where I implemented Caveman. And I did this after my token efficiency. So you could do this. So I did a light, a full, and an ultra for Caveman. And you could turn it on or off. And I actually credited the person who invented it based on Julia Bruce's MIT license Caveman prompt pattern. Code paths, commands, and strings, and safety warnings stay exact. And I could change this however. Let's go to ultra here. Let's see if that makes a difference. And since I logged me out, it kicked me out of my team here. Let's reload that. See, it's buggy still. It's not perfect. Let's bring that back up. Well, that didn't help. Yeah, I don't have anybody right now. It's okay. We'll rebuild the team again. Jerks. Let's do 2 coders. One auditor. I want a devs ops this time. Let's do a devs ops. And then QA. And then let's do an architect. There we go. Yes, I really did include it in Caveman afterwards. Someone brought it up to me. They're like, do you use Caveman? I'm like, I didn't even know what that was. And I had to do some research on it. I'm like, that's pretty cool. So I included it into my task here. I'm going to see if I can get more token efficiency. Let me actually, let me reset this and see if I can get better token efficiency with, because I turned it on to full. Hey, Neil, how's it going? Can you share how the software works under the hood, how the agents work, the team broadcasting, passes of the context, so on? So I can't show you the source code, if that's what you're asking. I got to explain it to you, though. So here's my team. Of course, half that's not true because of the roster here. So I'm going to have to fix that. I had to close out. But anyways, this is how the broadcasting works. Hang on here. When you have a second, I got logged out, and then I lost the team. They didn't get reloaded, so I had to start up new teams here. So in your roster, find the ones that aren't in your current team and remove them out of your roster, please. I want to learn too. Yeah, me too. That's what we're all here for. We're all learning. I don't know how to, so right now I'm building my own programming language. I've never done it before, and I'm learning as I go. So right now, how this works, my director has built-in tools in the terminal that it can use to either broadcast or to manage his team. He can even spawn his own team or spawn agents or change their skills. My director has full power over all that. And right now he's going to clean up my roster here. Do you have any proof that your outputs are the same after 99? I mean, my proof is my subscription. You see how many agents I'm running? I'm running 7 total agents right now. I do this daily, every single day. And right now for my codecs, I run Pro, the $100 subscription, and I don't run out. If I'm using the desktop here, I run out. And I run out fast. Using my tool, I don't run out. It moves it a lot slower. So right now I'm at the 48% token savings. Is director the same as orchestrator? Orchestration or orchestrator or orchestration is an action. My director orchestrates the team, if that makes sense. So the director, he's the director. Like, think of it like you're a CEO of a company, and you have a vision or an idea or a goal. So you tell the directors, hey, this is my vision, my goal. This is what we're going to do this year. The director says, okay, boss man wants this done. So the rest of his team underneath him, the director's going to spread that out to the rest of the team. That's how businesses and companies work. So that's how I made this. It's been working for years. So You'll support my journey. Thank you. What made you want to create PlyQ? One reason is because I wanted to learn what it takes to develop your own language. That's not what this is called. This is called Plyrium Forge, but I'm using this to build my own programming language. Two is because the foundation that I'm building it on is different and hasn't been done yet. So like you have Java, which is using their virtual environment to run on multiple different types of machines and hardware. You have Rust, which is using their own virtual environment, which also does the same thing. And React is one also. There's several other ones out there. They run on virtual environments. But those virtual environments are like the x86 machines that are, they're just virtual machines. So mine is also a virtual machine, but what makes mine different is I'm doing it, I have a virtual quantum computer machine. So my VM is a quantum computer. It's a low-level quantum virtual machine. And I'm going to build my language on top of that. So that's what makes it different. Yep, I'm building a brand new programming language. Whether it works or not, I don't know. I'm learning as you guys are. I've never done this before. So he cleared up the roster. All right, one thing that, go ahead and get the cards working. One thing we're trying to figure out is the qubit ownership. And do we know if we got that implemented yet for the qubit ownership? C-U-B-I-T? No, it's not going to do qubit. So after the first run of the type IR ownership validation foundations, good. Commands, state ops, consume user, okay, effect, missing. Okay, whatever's missing, it looks like you're missing the effect validation. Go ahead and get that implemented. I want that fully implemented in. Why we need it. Yeah. Measurement changes, collapse, resources, state, feature. Function needs say parameter passing, owned, borrowed, mutable, borrowed, moved, measured, consumed. Okay. All right. So x86 can't use your tool. No, you can use my tool. Of course you can. Yeah. So Johnny, my machine's an x86, and I've already I'm running a virtual quantum computer on it right now. That's what I'm building this on. Why use the LLQVM? What does run on the quantum computer? How it makes sense? So it can calculate algorithms so much faster, like so much faster than your regular native CPU or GPU can do. So my idea was to build a quantum computer that can calculate like very fast algorithms at lightning speeds compared to what your regular computer does. But imagine doing that and building an operating system that's that much faster, or an application like my Plyrium Forge here. Imagine if I build my Plyrium Forge on my PlyQ instead. The calculations that it takes for the algorithm is going to be so much faster and a lot quicker. It'll be run a lot smoother. So that's the idea behind it. If it works, I don't know. So far, it looks like it's going to. So have you published any research papers on this? No, not yet. I haven't published any research papers on this. I actually, did you know that I actually have paperwork or published work out there? A lot of people don't know that. If you do, I'll be surprised. But I have paperwork that I've actually had published out there. Let me show you here. Oh, not in there. So this is one of my published works. This is, I had a question that I asked myself. I'm like, what if time had geometry to it? What if it had if it was a particle? And I started digging deep into it, did a lot of research on it. In fact, down here, I'll show you all the studies that I've done, and I reference them down here. So these are all the papers that I've actually read and studied. Most of these are on cosmology, quantum physics, and things like that. And I did a lot of research on it. And based on their research and their findings, I was able to extrapolate my work, and I built a formula, this is it right here, that I was able to track two mass scalars. One is a disformal scalar, and the other one's a formal scalar. One's a 2F, and the other one's a 1F. And they're harmonized. And one's a very low frequency, and the other one's a very high frequency, but they match the same frequency as clock data. And I can take, which is the delta time here, the square. So I can take Einstein's general relativity, and this can add to that. Instead of it just being a base parameter, I actually have a physical object that you can base it off of now. And it's the dark energy that's out there. And so this is, I don't know if it's in nature. That's not what this proves. This is a falsifiable paperwork. If it does exist, this paper, my article here, it's a fingerprint to where to look and how to look for it using atomic clocks to be able to find it, if it does exist. So, and this is the observable harmonic structure here. But I wrote this paper, and I have several other papers that I've written and published. So, but for my language here, no, I don't think I'm going to publish a paper on it. But I will make it open source. It is not a peer-reviewed paper, Johnny. It is on Zando, and I tried getting it over to AXWI, whatever it is, but I don't have a college email to be able to publish it there. I had to send it to someone for them to be able to publish it for me. But it is published on Zando, I think is the name of it. Is this my own? No, I already have several LLMs that I've created from scratch, but I would love to create an LLM with my own language. I think that'd be kind of cool. What I'm describing is AI. What you're describing is AI. Oh, you're talking to someone else. I'm sorry. Have you read Team this Plyrium software? Oh, not only have I red teamed it, also Gray Hat teamed it. And if you're familiar with Gray Hat. What is the language for? What language are we talking about? My programming language? What's it for? For developing applications or whatever you want to develop. The continuum hypothesis, it sounds familiar. I'll have to look it up again. It sounds familiar though. So yeah, my language is for whatever you want to, like if you want to build a game, like a game engine with it, you can. If you want to build a desktop application, tools, if you want to, I actually want to make it where you can build websites with it. If you want to make your own operating system, if you want to run it on Raspberry Pi, you should be able to. That's my goal. It's not there yet. So right now, it's just all talk, no show right now. I'm actually just building the VM as we speak, and it is working. I do got the VM working, but I'm fine tuning it. And the big thing was, so here's the architecture flow here. So right now, this LLQVM, the bytecode and the runtime, that's what I'm currently building right now, and the backend adapters. And once that's all built, that's my foundation, I can actually start building the rest of this. And the very end is the actual source code that you use to write programs using my programming language. So I can't wait to get to that point. But that's how that looks. So I'm so happy that I built the IDE for my work. Way faster results. Yeah, that's awesome. Would be very helpful after it gets open source and Congo for your hard work. Yeah, I will open source this. Definitely. Well, that paper is loaded, understood the concept to an extent, but the equations and formula language looks difficult to digest. Yeah. Have you tried PewDiePie's AI by any chance? I have not. I looked into it. His Odysseus, something like that. I think what he built was freaking amazing. That's awesome. Now, I would like to try it, though. I haven't tried it yet, though. Now, if you guys aren't familiar with what PewDiePie's been up to, that dude he's went total tech guru. What he's building and what he's doing is freaking, it'll just blow your mind. It's amazing. This may sound stupid, but why another programming language? What will be the main difference to the most other? So the people who created Rust, I bet they had people asking that too. And the people who created Python, I bet they had people asking that too. There's a lot of reasons why you would want to create one. For me, it's for learning. I've never created one. I want to know what it takes to be able to create one from the ground up. Secondly, I'm doing something that has not been done yet, and it's not out there right now. So I am taking my language and the environment it's going to be run on, that's going to be compiled into the bytecode, is going to be a quantum computer virtual machine that you can run on your local computer. So imagine being able to run a quantum computer on your machine, and the application is going to be ran based on a quantum computer environment. It's going to be so much faster. The algorithms, the efficiency, it's just going to be so much faster. So that's the second thing. It hasn't been done yet. So that's what I'm doing. Yeah, people build stuff and open source is always awesome. Yeah, it is. Not security red team so much, rather adversarial product manage red team, theater versus functionality. So project manager red team, theater versus functionality. It has issues, if that's what you're getting at, and there's a lot of bug fixes that need to be done. So I am not a professional software developer by any means. Never have been, never claimed to be. I build things for me, and for you guys, if you guys want to use it and share it. And this is how I learn. I'm a hands-on learner. So I built this tool, I built my SaaS, and I built all sorts of tools. I don't even know if I showed you my SaaS yet. Let me show you here. So this is my SaaS right here. It's it's called Plyrium.com, but it's a total backend system, like a whole suite of tools for companies that run industries like plumbers, HVAC, electrical companies. And this tool here, and when they're out in the field, like what made me come up with this was one day I needed a plumber for some reason. And I called 5 different plumbers trying to get one to come out here. And I didn't care which one picked up. I was ready, I had an emergency and I was ready to throw my money at them. But I called 5 different plumbers and none of them was able to answer the phone, went to voicemail, or they couldn't get to me or anything like that. So by the time I got to a plumber, that's the one that I was able to get over and to pay. But that brought up an idea. That's a common thing that happens to a lot of these industries. Electrician, a roofer, HVAC, any of those type of industries that you have an emergency, like, you need someone right away. And the techs are out there in the field. They don't have time to answer the phones. Or their receptionist, a small business, the receptionist is most likely their wife or their mom or sister. They don't got time to deal with the kids or at home and manage their business while their husband's out there, plunging a toilet. So I built this tool that does an AI receptionist, It has AI automation, and it's an entire scheduling system. It's got a whole back end, and I'll show you here. It does everything that you can think about. And I vibe coded this, by the way, the entire thing. So I come over here and look at the schedules. I can see all my text out in the field. I can see the range. If you're outside my range, sorry, we can't get to you. The AI knows all this stuff. AI can schedule, set appointments, assign text to it. It's got smart scheduling. You can view all your appointments. These are all my appointments here. Of course, this is a demo. I can view all my customers. I can actually, there's a history, like, Kathy here. I could actually see all the invoices, what was paid, if there's a scheduled appointment, what was the total payments they made. I can look at quotes, invoices. Let's see here. I have a total dispatching system here. I could see, someone's day, if there's like agreements that we have created, if there's certain projects that we're building on, like home recipe copper to PEX, we're going to replace all the copper lines and replace it with PEX. This is a project. I could quote this entire project here. This is all done through building it with AI. It even has a whole marketing system in here for your company, and AI can manage your marketing for you. Your Google business profile. It can answer your reviews for you. So, like here's some reviews. And AI can come over here and you can market post. You can see what the AI wrote. You could open Google. You can save the draft. AI wrote all this stuff here to help the business owner out, to be able to answer people's reviews. So this is a whole tool, whole suite of tools. So I built that not knowing how to build a SaaS in my life. Didn't even know where to start. Just an idea. Everything I built was just an idea. Like my Whisper tool here that I built. I never built one before. I didn't know what it would take, how to do any of this. I was like, I want one that's local on my machine. I don't want to share my anytime I talk, all my history here. I don't want to share that with some server that's some company I don't know. Like Microsoft, they have one built in. You hit Windows key and H, and there it is. I can use that one, but you have to be online to use it, and they get everything you say to it gets sent to Microsoft. No, they don't need to know that. So I built this, and this you could actually run it on your CPU, on your GPU, whatever you decide you want to run it on. So, and I also built my ADE, all from an idea. So right now, my next idea is I want to build my own programming language. You should scrape all plumbers and HVAC workers on Google and Maps and market them by email and Sims. I don't want to do it that way. I am an honest business owner, and if I reach out to someone, I want to be treated the way I want to treat them the way I would want to be treated. I hate cold emails. I hate cold calls. I would take them and go sit down and have coffee with them and talk to them from person to person. I would want to show them the benefits of it. And I actually have subscribers on it right now. So it's moving up. I'm so happy that I built, okay, I already said that. This may sound stupid. Okay. And by the way, there is no such thing as a stupid question. You guys can ask whatever you want. What am I building? I'm building my own programming language. In fact, right now I'm building nothing because they're just sitting there. Hang on here. Let's get them working. Now with everything implemented, can we go ahead and do a benchmark comparison with the VM versus native? So I've been running these comparisons. It'll run different types of algorithms so I can test the speed on native versus my quantum computer. Yeah, every great invention starts with, yeah, that's true. Yeah, I'm not a software dev. I'm making a law firm software for my dad. I just often ask Claude in a theater or just functionality for each part. Yeah, and that's all you need to do. Just if you have questions, that's what AI is great for. Ask it questions. Have Claude Codex be adversarial and cynical. Yeah. What model does the voice LLM use? So I'm using Whisper, the open Whisper, because it's multilingual. And since I'm selling it to anybody, you know, it's just a one-time fee and you get a license, then you register it and you get it forever. But it's multilingual, so anybody in the world can use it. What model? Okay, tell me about yourself, your background, and stuff new here. So I am a Microsoft 365 engineer or architect, and I work for a large company, and I manage their entire cloud infrastructure. 60 watching is insane. I know, dude, you have no idea how crazy this is. I've never had this many watchers at the same time. This is awesome. When did this happen? When did what happen? I'm missing some context there. Are you building it in your own? Do you have any team in your back end actually? No, I build all this on my own. I don't have a team. My team is you guys and my AI. You guys are my team. This is it. So believe it or not, a lot of this was steered and formed by your guys' suggestions and ideas. So while I'm developing this, I take everything you guys say and I learn from it. I learn from you guys as much as I learn from either AI or do my own research. That's why I love the live stream. Oh, we're up to 70 viewers now. Oh, man. That's insane. Are you building it in your, yeah, I already answered that. How's life? Life's great, man. Life is so great. Okay, so we are faster. So we did some algorithm tests here. So this is my quantum computer, my virtual quantum computer running on my laptop right now. And these are different algorithms that I'm running on. So I am about only 1.31 times faster on the sparse chain, but the sparse H12, I am 2.61 million times faster. That is insane. And look how long, so my CPU, this is how long it took my CPU to run this algorithm. 136 milliseconds versus how long that my virtual quantum computer took. Now, these are my denses here. So I got dense and I got sparse. And I told it not to use dense anymore. So hang on here. So I thought we were only going to be using dense. We're not using sparse. And plus, you had to vectorize the dense. Didn't we talk about this? And I think that'll help speed it up there because that's insanely slow. And that's the Groover search. So using 12 qubits. Costly Oracle. So I am definitely faster on the Costly Oracle using the qubits. So 12 qubits times 32. So 109 seconds. Yeah, that's tremendously faster there. So, and that's the whole point of using a quantum computer for programming language. I think this is going to be insane if this works. Yeah, this is just these are all, so I built, this is a whole ADE software. I built this whole thing. But yeah, each one of these is just a terminal. That's all it is. How much do you burn on AI? No, it's not local. No, I use Codex. I have Codex and Claude, and I just have the subscription. So like the Codex, these are all Codex right here. I have 7 Codex terminals running right now, and I can run them all, and it hardly burns anything. So I have a built-in token efficiency built into it. So right now I'm getting 46% token efficiency. Let's see. Yes, we talked to the policy landed in double first. Not dense only, meaning runtime. Okay, why sparse still appears in benchmarks. Dense. Okay, so what about the vectorization? Where were we at with that? So general governor diffuser arbitrary circuits. Yeah, that's dense. Compile costly Oracle. Future log. Okay. But what about the vectorization? Because before you said that you weren't including a full vectorization, but now we should be doing that, especially in a dense, right? Future large dense, yeah, it's not a, correct. We have not done full dense vectorization. Yeah, we need to. Yeah, let's go ahead and implement that now. We definitely need to get that done. And plus finish up the qubit ownership, the total architecture for that. Which company do you work for? I won't mention that. Sorry. That's one thing I won't say. I do work for a large company. And it's one of the Fortune 500s. I think social media will be a big play for you. if you go all in on it, it can bring software more user. Yeah, I'm not very good at social media. I'm really not. And that's something I would like to be. Almost 80 people watchers. Wow. But yeah, I'm not good at social media. That's something I'm learning how to do. Hi, is it Ibu? Hi, how's it going? Right now, I'm building my own. For anybody that's just joining, I'm building my own programming language from scratch. I actually started. I've been streaming for 6 hours and 44 minutes, so almost 7 hours ago. I've started building this from scratch, and the core of it is the main core. It's going to be running in its own virtual environment, like Java does, and how Rust does. They run in their own virtual environment, their own VM. And my virtual environment is not going to be a regular like an x86 based computer for the VM. I'm actually going to be running it as a qubit, or not qubit, a quantum computer VM. And then my language is going to be on top of that. So dense vectorization is coder 2, finish ownership, effect validation. Yeah, that's important too. And QA, hold ownership. Perfect. We're rolling now. You're natural at social media. I don't know. I mean, talking to you guys, that's easy because you guys are all smart. You guys understand and get what I'm doing most of the time. But I just love talking to you guys. But actually sitting there typing stuff on social media, I'm not that good at it. Why am I using Codex? Because I like Codex. I have Claude and Codex. I've been mad at Claude. They've been having issues, and I'm probably going to cancel my subscription with them. They just been pissing me off lately. Every time I use them, I end up they've been having server issues, or like it just wasn't doing their some of the designing wasn't getting it right. So I switched to Codex, and Codex has been really good. So they both have their goods and bads about them, both of them. Code from your own. Why are you using Codex code from your own? Well, I don't know what you mean by that. Like, you want me to program it from scratch? I'm not a software developer. I never claimed to be. I'm learning as I go here. I mean, I've written a lot of programs that I can write in different programs. Like I could do C#, PowerShell, Java, because that's a lot like C#, and then Python. What else? That's about it. HTML, CSS, I could do that. But I'm not an expert at it. Never have been. Just write your AR in the title. I'll show you my AR. I ain't no shameful person here. That's my AR currently right now. Yeah, let me refresh here. Yep, that's my current AR. But I mentioned my AR on my vibe coding until I reach my goal. This is a little bit different. I'm not really showing off my AR on this. This is just me having a little bit of fun on the side and doing something a little bit different. What do you mean part of the app was blocked? So POKQ, what does this mean and why are you being blocked? Hey, come on. Can I even capture that? Is it going to capture that? It did. So can you look into this, see why this is being blocked? Yeah, I agree with that, Kenneth. And that's what I'm actually working on that. One of them here, let me show you guys here. I showed this earlier, so some of you might have missed it. One of my free tools I'm going to be giving to you guys, it's my Securium here. Go ahead and launch Securium again. How much money do I earn in a day? I think it's like per day? I don't know how much I earn per day, but per month, MRR is 155, so AR is 1860, so not a whole lot. But if you're talking about what I earn for my job, that's separate. That's private. But for my hobby here and what I do here, I'll share all that with you guys. But, oh man, I'm getting tired. When this loads here. Oh, I was like, why is this running? But I forgot I had that up. I found the socket listener network code and you can pass on identifier stream. Okay, most likely cause Windows Security Smart App Control. I hate the Windows Security Smart App crap. Freshly built, unsigned Rust test executable under, yeah. I'm building my own freaking programming language. I shouldn't have this problem. Oh, yeah, here we go. Okay, so here's going to be my free app that I'm going to be launching. It's still in early alpha, but I'm going to be building this. This is my Securium, and it has a built-in terminal too, so you can actually run either Claude or Codex or anything like that into it, or open code, whatever you decide. And then there's tools in here inside this terminal that it can run any part of this application for you. But what this is for is it'll check if your application or website has any exploits, vulnerabilities, security data leaks, or anything like that. And it actually is based off of, first it's going to be AI, so AI can help scan for it. And the other thing is that there's going to be a list of databases that it'll check. So here's all the databases. We're going to have Metasploit, Microsoft Security, the EPS, the CISA or CISA, National Vulnerability Database, Open Source Vulnerabilities, and the GitHub Advisory Database. So I have a whole list of databases that it's going to be able to find any of these type of exploits, vulnerabilities, or hacks or anything. And it'll check your application to see if first of all, if you're vulnerable to any of these. And it'll tell you how to fix them. This is for reporting only. And it's not intrusive. So you could actually, some of it's functional, some of it's not. Like if I had a website, I could scan my website, and then I can actually see, I could actually do like reverse proxy lookups to see if I can inject any payloads into it, or reverse to see if I can do proxy retries based on the API callbacks. And from there I could do a JSON payload. And like I could change, for instance, I could take your subscription that you have from your SaaS, and I could set up a reverse proxy where it'll come back to my proxy, and then I could actually do a fake callback to make it look like that I paid for the app, and I can log in, right? That's an example of a way you can actually get into websites, and vibe coders don't know that, and they leave their websites exposed. This is supposed to check all that for you. So it's, like I said, it's still in alpha, still needs a lot of work, but this is another tool I'm working on. And I'm going to be making it open source for you guys. CVEs are coming for PlyQ. I don't know, what are CVEs? I don't know what CVEs are. Hey, don't you treat me like that. I'm going to have to Google it now because I have no idea what the hell you're talking about. And once I look it up, I'm going to feel stupid. I'm not going to, no, I'm going to see what it is. Common vulnerabilities and exposures? Is that what you mean? Everyone knows them? CVEs are coming for play. Yeah. I don't, honestly, I've never heard of CVEs. Is this what you mean? Common vulnerabilities and exposures? A dictionary of common names, identifiers? Yes, for coding experience. And yeah, and I never claimed to be a software engineer, sorry. What is CVE? Maybe it's, I just don't, maybe there's a different context for it. Common vulnerabilities and exposures, yeah. Disclose computer security flaws when someone refers to, so you're saying that I'm going to have some security flaws in my programming language? Oh, I probably would. Oh, definitely. I'm sure. If that's what you're getting at. I can't wait for that. Once the DINS is vectorized, I think it's going to help speed up tremendously. This is like boring music. What are we listening to? What is this crap? Yeah. Where I'm from the U.S. So we're just waiting for the architect or the auditor. Well, it looks like the architect is done, and it looks like the only one that's running right now is the auditor. Although your roster is showing everyone's working, and that's not true. The only one working right now is your auditor, too. I do the $100 a month for Codex. Their Pro. I don't do that X 20 times. I haven't needed it yet. If I'm this is my tool here. If I'm doing developing in my tool here, I hardly ever run into an issue where I run out. I actually have built-in token efficiency, and it works really good. But if I'm using their desktop here, oh, I'll sit there and eat through it like crazy. Like if I come to my usage here, yeah. Like right now, I hardly ever eat through this. You're from China? Do you have a tattoo on your foot that says made in China? If I was Chinese, I definitely would. Because that's just awesome. Made in China. Like on the bottom of your foot or something. I'm building my own programming language from scratch. Why would companies actually keep application engineers when there are people working on both back and front end? It just depends on the company, I guess, and their needs and how big the application is. Welcome to China. I know, huh? I gotta admit, man, I love Chinese food. You guys have some of the best food out there. That and Mexican food. That's my two go-tos all the time. When I go out to eat, it's like, what are we eating? Chinese or Mexican? Pick one. What's up, Zeph? Will AI impact web development jobs? To a certain extent, it could. But so there's a lot of companies who realize, so think of it this way. Let's just say you got these large companies and they fire their junior developers. And because why do we need junior developers? We have AI now. Let's just keep the seniors. Well, they save a few bucks doing it that way, sure. But now in another 10 years, their senior developers are retiring or moving on or doing something else. Now that company's screwed because AI still ain't good enough to run their company. And they fired their senior developers who they could have been training and teaching on how to become a junior developer. Companies know this and they won't do that to themselves. In fact, there's been a lot of talks and communication with these companies who tried to bring in AI and realized it's a mistake. It's okay to adapt AI into your workflow. And a lot of companies are doing that for better productivity, but they are not going to get rid of the developer. And there's a difference between a vibe coder and an agentic engineer. An agentic engineer is someone who, like if you're programming, you're developing something, you hit tab and it auto-completes. AI auto-completed that, but you're still developing. The other part of an agentic engineer is someone who actually can look at the source code and understand it from head to toe, can read the entire source code. So yes, it's okay to vibe code, but agentic engineers will actually open up the source code and read it to make sure it's what they want. Because big, large companies, they have code reviews. And it's so important. And also quality assurance that they go through before they release things. For example, Amazon, that's a huge SaaS, big SaaS. And anytime they do an update or any changes or anything like that, they can't just have a bunch of AI building on that and hoping it'll work. They would go out of business real fast. So I don't think it's going to be taking jobs. How many days do you think this could take up to? So I just started today. I'm thinking I will have it where I can start writing my own programs in it by the end of this weekend. I've been taking care of you for a long time. Love you a long time too. I've been following you for a long time. Okay. Well, good. Thank you. Yeah, I have some regulars in here, and then I have a lot of new people, and I think everyone comes in has been great so far. Bro, got 6 AI models running at the same time. Damn, I can't even pay for it. No, I mean, that's what I love about my tool here. It does serious token efficiency. I only pay for the $100 subscription on this. I talk to people, they're like, yeah, I got 3 Claude Pro X20 subscriptions. It's like, dude, that's $600 a month. You pay for that? What kind of programming do you do? I do this nonstop all day long, guys. I literally vibe code all day, nonstop. I mean, it's 2 in the morning for me. I'm still going. So usually I'd be in bed by now, but from 6 a.m. in the morning, well, 5 a.m. in the morning, all day long, I'm vibe coding, doing something. Are you on? No, I don't own my own company. I mean, this is what I do. I actually work for a large company. Do you still write code? I used to, but I mean, I guess I do for my job. I do a lot of PowerShell automation. So I do write code in that sense. I used to do C#, but I kind of steered away from that. And I do more PowerShell right now. And I do that because of my job that I do. I'm a 365 architect. I work for a large company and I manage their entire Microsoft cloud infrastructure. So there's a lot of reports that I pull, and I write PowerShell scripts to pull a lot of reports and stuff. How much does what cost? My tool? I'll send you a link. If you guys want it, if you want to download it, play with it. So I have two of them. So my speech to talk, this is awesome. I built this too. And this runs locally on your computer. It doesn't connect to a server or anything. I didn't like the idea of having a speech to talk that connects to a server, and everything you talk to it gets sent to some server. So I didn't like that. So I created my own, and it's all local. I could be disconnected from the internet and run this, and it works just fine. Yeah, it doesn't connect online at all. And you can run it on almost any hardware, any computer, because you got 3 different choices between your model here, and they're multilingual models. I'm using the Open Whisper. So you got the small, which can run on your CPU, medium, and large. So whatever you prefer. I ran an entire day running on small. I didn't even realize I was on small. So it's just as good as the large one. And like I said, it's multilingual. So yeah, exactly. I don't think they would fire the engineers. And when they include AI into into the company, it's to help the productivity of the company, to where you can develop faster, push things out a little bit quicker, do your research faster. It's just a tool that makes your job easier, is what it is. You want to follow me? You can definitely follow me. I don't have a TikTok account. No, I'm sorry. I am a fresher looking to start my career as a Spring Boot developer. I don't even know what a Spring Boot developer is. Could you please share some insight on the current job prospects and how an entry-level candidate can stand out? Experience. Like me, I have no certificates. I never went to college, and I dropped out of high school. I got my GED, but I am self-taught. And everything I learned was because, I hit the books, and I've also studied as much as I can to get my foot in the door, and to get to where I'm at today. So, and I'm still constantly learning. I'm always learning. I never stop learning. And honestly, when you make mistakes, you can learn from your mistakes. It is okay to make mistakes. Be honest about it. Be honest with yourself, and don't be afraid to learn from it. That's what they're there for. I don't. I mean, where do you write with 6 models at the same time, and how much does it cost? I only have one subscription. All these 6 models, I actually have 7 models if you think about it, because my director is also a model. So I'm actually running 7 models here, and they are all run at the same time. Okay, everybody's on idle. Put everybody to work. I got tasks lined up. They need to get it done. But yeah, I have 7 models that's running right now, and they're all using the same subscription. What's up, Buffer? But guys, I hate to do this. I really do. Because I've been streaming for 7 hours now. I'm losing my voice. And it's already almost 3 o'clock in the morning. I have to get up early tomorrow. And I will be streaming tomorrow, though. So I'm gonna have to log off here, get off. I really appreciate all you guys. I really do. Sorry for the ones that are just coming in and going to be missing this. But check out my channel. Subscribe to me if you haven't. Like the video, please. It really helps. And I'll be streaming tomorrow and the next day, this whole weekend. So, and I'm going to continue working on my my programming language here. See, I'm getting tired. I can't even think anymore. What is vibe coding and noun for the future? Vibe coding. You just talk to your AI and have it do the coding for you. You're welcome. You guys have a wonderful evening or morning or whatever it is, and wherever you're at. I appreciate all of you. So, but I'll be on tomorrow. And like I said, go ahead and subscribe to me if you can. Thank you all. You guys are all great. I really appreciate everything.